Right now, today we are going to discuss about the electrochemistry, right? So, basically this question comes under the question number 7 in your A-level, right? A-level question number 7 with the coordination chemistry part, right? When it comes to question number 7, 75 marks are allocated for the coordination chemistry, the coordination complexes, D block complexes, and the rest, the next 75, right, is allocated for the electrochemistry, right? That is where the electrochemistry question, the unit 13 question, comes in your A-level paper, right? And basically there will be at least 2 MCQs, sometimes it could be 3 MCQs, right? Definitely 2 MCQs are there from the electrochemistry, right? So that more than 6 marks will be allocated for the electrochemistry, right? 6 to, yeah, definitely 6 marks are there, right? 80 from the 75 from that part, from the essay part, and 2 MCQs will be there. 6 to 7 marks will be definitely allocated for this part, right? So it's a very small unit. Today we are going to complete this part, right? If we are not unable to do, if we were unable to do that, we'll continue with the night sessions as well. And anyway, with this week's work, we are trying to complete this whole the theory part, right? Okay. And the rest, I have to tell you, the next week you don't have classes, right? Sahasra is closed, Sahasra Wahala, right? So next week classes nahe. But after that, we'll start with the other 2 parts to discuss for this month. So we are going to discuss the physical chemistry stuff here with this month, right? So we are going to discuss the chemical kinetics and the 5th unit, energetics. Those are the 2 things we will do, right, with this month. හරිද? මේ දෙකත් අපි දවස් දෙකක් කරමු. kinetics වලට දවසක් දෙන්නම්. සහ මේ energetics වලට දවසක් දෙන්න තමයි plan එක තියෙන්නේ. හරි, weeks 3යි තියෙන්නේ. 4ක් නෑ. 4කට තමයි plan කරේ. So ඊටු එක තිබ්බේ අතර අපි කොහොම හරි industrial chemistry දවසක් කරන්න කියලා තමයි plan එක තිබ්බේ. කවන්න ඒක වෙන විදිහට කරමු. ඒක ඊළඟ month එක first week එකේ හරි මොකක් හරි විදිහට කරමු. industrial chemistry වල short note set එකක් කතා කරන් තමයි තියෙන්නේ. ඒකත් plan එකක් තිබ්බා. but මේ month එකේ අපේ weeks 3ක් විතරක් හම්බ වෙන නිසා ඉතින් දැන් අපිට කරන්න වෙන්නේ ওই 3 තමයි. electrochemistry අද කරන්නේ මේ week එකේ. ඊට පස්සේ week එකේ energetics, kinetics ඔය දෙකෙන් එකක් කරනවා. දැන් මට කියන්න බෑ මොකද short note set එක තාම print එකමින් තියෙන්නේ. print එක ready වෙන එක තමයි කරන්නේ. හරි. ඒක දෙකම ready වෙයි හුඟක් වෙලාවට. ඒක මම ඔයගොල්ලෝ message එකක් දාන්නම්. මොකද next week free නිසා type setting එක set වෙන එක තමයි. හරි. එතකොට මේ හරි. එහෙනම් අපි electrochemistry පටන් ගමු. හරි. when it comes to electrochemistry ළමයි, right? 3 parts are there in this whole lesson. We have 3 major sections. First, we are going to discuss about the electrochemical cell. Electrochemical cell, where a spontaneous redox reaction occurs, right? Delta G negative reaction occurs, spontaneous redox reaction occurs, right? And basically, the electric energy will be generated from this one, right? We are trying to generate electric energy, right, from electrochemical cell processes where some spontaneous redox reactions occur, right? And the second part of this thing coming up with the electrolytic cells. Electrolytic cells, right? They are a non-spontaneous redox reaction occur, DTG positive redox reaction occur. Actually, with the supply amount of electric energy. Electric energy is used for these processes. So if you need some examples, so those processes involving electroplating, right? So cylinder plating stuff, right? Involves the electrolytic cell process, right? And then we have another part, very little part, very small part regarding actually conductivity of solutions. Normally this is concentrated on MCQs, right? There could be one MCQ. Normally when it comes to last 5 years, right, only one MCQ appeared from there, very little section. most of the times questions won't be asked, right? And sometimes at the end of the essay question, maybe 5 marks, maybe 5 marks from 75 marks could be there from this section, conductivity, right? With this short note, we are mainly concentrating on these two things, right? We'll discuss about the conductivity stuff, right, when we are doing the papers. Very little stuff, nothing to discuss actually there with the conductivity, right? Only 3 factors affecting the conductivity, and we have to discuss that thing. That is all, right? So 10 minute stuff, right? So basically with this tute, right, we are doing these 2 parts, the major 2 parts of the electrochemistry unit 13, right? Okay, we'll start with the electrochemical cell. So I have planned to complete the electrochemical cell at the first session here, and plan right, we supposed to complete the electrolytic cell at the second session. Let's try that, right? Okay, try it. Ready? Let's start with the electrochemical cells, right? Okay. Right. Electrochemical cell. So electrochemical cells are normal cells, right? Okay, electrochemical cell. Electrochemical cell. Right? Normally the cells are constructed with half cells, right? So if you need to come up with some generalized form of electrochemical cell, normally you could see these kind of pictures, right? This is some general picture of an electrochemical cell, and so what you are going to learn here with this stuff, right? So example for an electrochemical cell. Right? So cells are normally constructed with half cells. One half of this cell is referred to as a half cell. Right? This is another half cell. Right? 2 halves will give you the total cell. Right? Okay. At 1 half cell, the oxidation will occur. Right, when you connect the cell to a closed circuit, when you connect the cell to a closed circuit, right, 1 half cell, right, there will be oxidation. The electrons will be removed from 1 half cell, and from the other half cell, those electrons will be gained, right? So 1 half cell coming up with the oxidation, and the other half cell coming up with the reduction. So there will be a redox reaction, right, when you think about the total cell, right? So spontaneous redox reaction will occur. Spontaneous, that means delta G negative, redox reaction will occur. When a cell is at work, right? 2 half cells are there, right, where the oxidation occurs and where the reduction occurs, reduction occurs, right? This is what you are going to learn today, right? Normally the 2 half cells are connected by a connecting method. We will discuss about the connecting methods as well. Here a Sol bridge is used, right? Okay. And the 2 half cells which will undergo the oxidation we refer to as the anode, and the other half cell where the reduction occurs we refer to as the cathode, right? So those are the anode and the cathode of your cell. Those are familiar terms, no, with the cells, anodes and cathodes. Anode means the half cell where the oxidation occurs. Cathode means the half cell where the reduction occurs. This is the general picture of a cell, right? See, electrons are removing from this half cell, that means reduction occurs. Electrons are coming towards this half cell, that means reduction occurs. Removing from the half cell, oxidation occurs, right? No? Okay. So let's discuss about these things, right? Okay. To start up with, first I'll describe you about the 4 types of half cells available, right? So connecting half cells will give you the total cell. We'll start the discussion with the knowledge of half cells, right? Half cells කෙන ඉගෙනගෙන අපි discussion එකෙන් පටන් ගමු. ඊට පස්සේ අපිට half cells දෙක connect කරලා total cell එක හදා ගන්න පුළුවන්, right? In our A level syllabus we have to study about 4 types of half cells. There are 4 types of half cells in our A level syllabus, right? Altogether we have more, right? ලෝකේ ළමයි half cells 4යි නෙමෙයි උගක් තියෙනවා. හරි? අපේ syllabus එකේ ඉන්නේ 4යි. Right? We start with that. Right? We start with the 4 types of half cells, right? In our A level syllabus, right? That is, those are the 4 types indicated at your first page, right? Okay. Okay. So you can write the topic there. Topic is not typed. Type kara na topic එක, right? First just put the topic 4 types of half cells in A level syllabus. 4 types of half cells in A level syllabus, right? That should be the topic for this short note, right? First page. Right? The first kind is referred to as metal ion electrodes. Right? These are half cells are also known as electrodes, right? Same thing, half cell කිව්වත් electrode කිව්වත් දෙකම එකම කතාවමද? වචනයක් විතරයි. බය වෙන්න දෙයක් නැහැ. අර half cell කියන concept එක කරලා තියෙන්නේ cell එකෙන් half එකක් කියන idea එකත් එක්ක. හරි? Technical term is electrode. හරිද? cell එකක් හදන්න අඩු ගානේ අර භාගයක් කියන idea තමයි ඔය half cell කියන concept එකේ දෙන්නේ. Half cell and electrode both are same, right? Okay. Okay, so one kind is metal ion electrodes. So you can say 4 types of half cells or 4 types of electrodes. Right. Metal ion electrodes. That means such kind of half cell or electrode is made out of a metal and a metal ion aqueous solution. Right? Okay. So if you need an example, right? Example. Let's think of magnesium 2+ electrode. Right? So there you have a magnesium rod. Dipped in a solution of magnesium 2+ aqueous ions. Right? Normally if you are regarding to a standard half cell, right, we'll come up with 1 mole concentration. Right now? So the standard states are used now. Right? In physical chemistry, such thing as standard states now. Standard conditions. What are the standard conditions? So we introduce those standard states and standard stuff with the enthalpy. No? What are the standard conditions available in physical chemistry? If it comes to temperature, it is 25 Celsius. Standard pressure is 1 atm or 110.5 pascals, right? So like that, for the solutions, we have standard situation for the concentration referred to as 1 mole solutions, right? Okay. So if you are regarding to a standard half cell, standard electrode, right? You have to maintain those conditions so that the aqueous solution should come up with 1 mole concentration, right? 1 mole concentration. So I am referring to a standard electrode. I'll write it as standard. Right? In this case, right? Standard magnesium 2+ electrode. Right? Okay. So if it is that standard term appears, definitely the concentration should be coming up with 1 mole. Right? For a gaseous electrode, it should be 1 atm like that. Right? Okay. Okay. Right. This is the simple form of a metal ion electrode, where a metal rod is dipped in a solution with the metal ion, right? But magnesium ge ion එක වෙන්න ඕනේ. If you coming up with some kind of copper, it should be the copper ion, copper 2+ aqueous. Sodium no, sodium plus aqueous like that, right? So metal with the metal ion aqueous solution. Metal is dipped in a solution with the same metal ion, right? Okay. So metal ion electrodes, right? That is the first kind, right? So we have such 4 types. Let's come up with the second kind as well, right? Second kind, metal ion electrodes. So another kind is, right, gas electrodes, right? Gas electrodes. Right? So if you need an example for that, standard, let's come up with standard, right? H plus H2 electrode. So when it comes to gas electrodes, definitely a gas will be there, right? A gas will be there as one of the components when it comes to gas electrodes, right? If you need some structure for a gas electrode, see, it's like, right, kind of gas is there. See, you have to introduce the gas here, H2 gas. When it comes to gas, right, standard situation 180, and connecting with kind of ionic solution. If it is a solution, you should come up with the 1 mole concentration. See how the standard states are used with the gases and aqueous solutions, right? If it is a standard electrode, definitely the gases should come up with 1 atm and solution should come up with 1 mole concentrations, right? Okay, this is a kind of a example for a standard electrode, standard hydrogen electrode. So there are platinum is also used, platinum thing is also used. We will discuss why is that, right? These are some examples for 2 kinds of electrodes, right? Okay, so I'll give you some time to draw this ones, right? Let's think of the reaction kinds possible with these electrodes. හරි මම කිව්වන ළමයි දැන් මේ ඔය electrodes දෙක මම ලිව්වේ හරි. ඔය ජාති electrode ජාති 4ක් තියෙනවා. හරිද? මේ metal ion electrode එක අර gas electrode එක. gas electrodes ඕන තරම් තියෙනවනේ. H plus H2 electrode. You can produce gas electrodes from any of the gases, you know, right? So like Cl minus Cl2 electrode. Gas is involved, Cl2 is gas. Kind of OH minus O2 electrode. O2 is kind of a gas, no? Right? With the use of a gas, you can construct gas electrodes. Right? electrode ජාති දෙකක්. තව ජාති දෙකක් තියෙනවා අපි දෙකක් කතා කරමු. හරි? හරි. ඊට කලින් අපි පොඩ්ඩක් කතා කරලමු මේගොල්ලන්ගේ කොහොමද මේ oxidation reduction වෙන්නේ කියලා. So I had earlier told you when it comes to electrode and when you are dealing with a closed circuit situation with your cell, definitely one electrode will get oxidized and the other electrode will get reduced. The one which is more keen to release electrons will release the electrons, and which is more keen to accept the electrons will accept those electrons, right? So when a cell is constructed, definitely one electrode will release electrons and one will accept those electrons. Reduction and oxidation will occur, right? Which one is to release or which one is to accept it is actually depend on their relative abilities of releasing the electrons and accepting the electrons, right? Anyway, electrodes are able to get oxidized as well as reduced, right? Okay. හරි. ඉතින් බලමු එහෙනම්. Let's discuss how this one will operate when it is right acting as a cathode. When this one is acting as a cathode, that means if this electrode is here in your cell, if this electrode is appearing here, then it is acting as a cathode, right? Let's discuss the reactions, right, which will occur inside the half cell day, right? එතකොට මෙයා කැතෝඩ් එකක් විදිහට නේ ඇඩ් කරන්නේ වාගේ සෙල් එකේදී අපි බලමු එයාගේ ඇතුලේ මොන වගේ රියැක්ෂන්ස්ද වෙන්නේ කියලා. හරි as a cathode. හරිද? Cathode means there should be a reduction. Definitely there should be a reduction. Right cat අමතක කරන්න එපා. හරිද? මේ ඉලෙක්ට්‍රෝකෙමිස්ට්‍රි කියන සම්පූර්ණ කතාව ඇතුළෙම red cat තමයි. හරිද? electrolysis කිව්වත් electrochemical cell කිව්වත් මේ සම්පූර්ණ කතාව ඇතුළෙම දවස් කතාව ඇතුළෙම red cat තමයි. ඒක රස් වෙන්නේ නැහැ. cathode reduction. Right? හරි. ඒක අමතක දිහා තමයි. අනිත් එක අනිත් කෙනාට. හරි. Let's try the reduction reaction here then. If it is acting at a cathode, that means definitely it should accept electrons, right? So that reduction should occur inside the cathode. See? So reduction. So when it comes to electrode, definitely two components are there with a higher oxidation state and a low oxidation state. Electrode එක හැදෙන්නම components දෙකකින් high oxidation state එකේ ඉන්න කෙනෙක් ඉන්නවා, low oxidation state එකේ ඉන්න කෙනෙක් ඉන්නවා. වාට මේවල් මම examples දෙකක් දුන්නේ ඒකයි වාට තේරුම් ගන්න. When it comes to this electrode, you have the plus 1 oxidation state with hydrogen, here is 0. හරි? So electrode එක අනිවාර්යෙන් හැදෙන්නම right high oxidation state එකේ ඉන්න element කෙනෙක් ගුණයි ඒ element ගෙම low oxidation state එකේ ඉන්න situation එක එක. හරිද? Right. So if it is acting as a cathode, what you need to do? As reaction should occur, you have to arrange the redox couple. These are known as redox couple, right? You have to arrange the redox couple of the electrode, right, in the form of, right, a reduction, in the form of reduction. That means in a way where the oxidation state should reduce going from reactant products. If you have to arrange the redox couple in such a manner, that means you are representing a reduction. That means you are representing your electrode as a cathode. Right? හරි එහෙනම් as a cathode නම් කොහොමද වැඩි සෙට් වෙන්නේ? එහෙනම් මේ දෙන්නම reduction එකක් වෙන විදිහට සෙට් කරන්න. ඒ oxygen set එක අඩු වෙන විදිහට arrange කරන්න. එතකොට oxygen set එක අඩු එක්කෙනා මෙයා වැඩි එක්කෙනා මෙයා. ඒ කියන්නේ we have to arrange these two guys as magnesium 2 plus the high oxygen state guy convert into the low oxygen state. Right? So if you are right thinking of a cathode acting as a cathode for this electrode, it should be like this. High oxygen state should convert to a low oxygen state. Reduction should occur. මේ රෙඩ් කියන එක ලියන්න ඕනේ. හරි මම වාට ඔලුවට යන්න ලිව්වේ. හරි. ඊට පස්සේ මොකද කරන්නේ? You have to balance this stuff, right? ඇත්තටම මේ පාඩම මාරම ලේසි. ඔයාට අර තුන්වෙනි පාඩමේ උගන්වන්නේ half reaction balancing technique කියලා එකක්. තුන්වෙනි පාඩමේ redox reaction balancing වල උගන්වන අපි ඔයාට half reaction balancing technique කියලා එකක්. හරි? ඒක පුළුවන් නම් මේ පාඩමේ ඇති දෙයක් නැහැ. half reaction balancing technique අපි ඔයගොල්ලෝ උගන්වන්නේ මේ වෙලේට ඕන නිසා. හරිද? right. දැන් මේක balance කරමුද half reaction එක? How to balance? So you have plus 2 here as the oxygen state, you have 0 here as the oxygen state, right? Oxygen state of a monoatomic ion is same as the charge, right? Here 0. So to balance the oxygen states, we are supposed to use the electrons. So you need to come up with 2 electrons at this side, right? half reaction balancing මතකයි නේද? මුලින්ම කරන්නේ redox atom එක balance කරන එක. ඊට පස්සේ කරන්නේ balancing the oxygen state with the use of electrons. දැන් මතක නම් ලියන්න ඒක. හරි. steps එක මොනවද? half reaction balancing state half මෙහෙන් ලියන්න. මෙහෙන් ලියන්න. හරි. half reaction balancing steps. දැන් මේක පුළුවන් වෙන්න ඕනේ. බලන්න මොකද්ද? balancing redox atom. Number 2, balancing oxidation state. For this one, use of electrons. තුන්වෙනි එක balancing the charge. charge වෙනස් නන්නේ. හරි. normal නම් අපි use කරන්නේ medium එකනේ. normally use කරන්නේ medium එක. right. හරි. හතරවෙනි එක right, balancing hydrogen and oxygen using H2O, right. Give it. කොහොමද තමයි half reaction එක balance කරන්නේ? හරි. use of electrons, use of H2O. ඉතින් ඔක තමයි සාමාන්‍ය half reaction balancing වලට උගන්වන්නේ. right මේ ඉතින් මේක පුළුවන් ඇති කියලා මම හිතනවා. ඉතින් බලමු ඉතින් බැරි වුණත් කමක් නැහැ. මේ වෙලාවේ ඉගෙන වැඩි කරන් යමු shape එක. හරි. right. okay. Let's come to this one. So here the atom is balanced. Then we have to balance the oxygen states. This plus 2 and 0. For that we have to use electrons. Then charge balancing with the use of medium normally, right? But here the charge is balanced, right? Minus 2 plus 2, it is 0. 0. Right? Okay. So it is balanced. Right. So this is the half reaction when this half cell or when this electrode acting as a cathode in your cell. Your cell එකේ මෙන්න මේ පැත්ත නම් වා හිටි cathode එක දිනවා සෙට් උනේ. හරි. ඕක තමයි මෙයාගේ වෙන change එක. half reaction. ඕක ලියා ගන්න පුළුවන් වෙන්න ඕන. Right? Say if you are acting as an anode, හිතන්න ඔයාගේ මේ magnesium magnesium 2+ කියන half cell එක cell එකේ මේ විදිහට electron release කරන half cell එක විදිහට use කරනවා කියලා. එහෙම වෙන්න පුළුවන්. හිතන්න හදිස්සියක් මේ පැත්තේ ඉන්නේ මෙයාට වඩා reduce වෙන්න කැමති කෙනෙක්. මේ පැත්තේ magnesium ට වඩා වැඩියෙන් reduce වෙන්න කැමති කෙනෙක් මේ පැත්තේ හිටියොත් set කරොත් ඔයා අනිවාර්යෙන් that guy will get reduced so that the magnesium electrode will get oxidized. හරිද? තොර තමන්ගේ ඉලෙක්ට්‍රෝඩ් එක ඔක්සිඩයිස් වෙනවා රිඩියුස් වෙනවාද කියලා තීරණය වෙන්නේ අනිත් පැත්තේ ඉන්න එක මත. හරිද? පැහැදිලි? හිතන්න ඔයාගේ magnesium 2+ ඉලෙක්ට්‍රෝඩ් එක මෙන්න මේ පැත්තේ. නැත්තම් රිඩියුස් වෙන්න වැඩියෙන් කැමති ඉලෙක්ට්‍රෝඩ් එකක් සෙට් කරා කියලා. එහෙනම් your magnesium 2+ electrode will get oxidized. In such a situation, Mg2+ electrode will act as an anode. Will get oxidized means acting as an anode, right? Okay. හිතන්න ඔයාගේ මෙයා anode එකක් ඇඩ් කරනවා කියලා. කියන්නේ their oxidation would occur with your half cell. Right? So then how to write the half reaction there? Oxidation නම් වෙන්නේ මොකද්ද කරන්න ඕනේ? ඔයාගේ redox couple එක place කරන්න ඕනේ. නේද? oxygen state එක වැඩි වෙන පිළිවෙලට. Oxidation, increasing oxygen state. So at the reactant side, you have to place the lower oxidation state, species with the lower oxidation state. At the product side, you have to place the species with the high oxidation state. Right? That is how we are supposed to come up with the half reaction when an oxidation would occur, right? So placing the redox couple in such a manner, right? So this is the low oxygen state, this is the high oxygen state. So starting from the low oxygen state, you have to come up with the high oxygen state. If such a change occurred, it's a oxidation, right? So then balancing. මුලින්ම මේ redox couple එක ලියන් ඉන්න. step by step වැඩට යන්න ඕනේ. එක සැරේ හැමදේම කරන්න එපා. මුලින්ම හරියට redox couple එක place කරගන්න. oxidation එක ගන්න, oxygen state එක වැඩි වෙන පිළිවෙලට. හරිද? ඊට පස්සේ balancing technique පටන් ගන්න. redox couple එක place කරලා පස්සේ balancing පටන් ගන්න. හරිද? right. එතකොට balancing. first the atomic balance. මෙතන බිඳුවයි මෙතන එකයි. sorry. මෙතනත් එකයි මෙතනත් එකයි right? That is balance. Then the oxygen state balancing. Here the oxygen state is 0, here the plus 2. To balance oxygen state we use electrons. So you have to put some 2 electrons at this side. Right? So oxygen state balance. Plus 2, minus 2, 0. Right? ඔය electrons වලින් එන oxygen state contribution එක ළමයි. ඒ electrons ගන්න තමයි. හරි වරෝන්න. දොරවන්නේ හරි. oxygen state එක වෙනස් වෙනවා electrons අඩු වෙන වෙනකොට. electrons remove වෙනවා කියන්නේ plus oxygen state. electrons gain කරනවා කියන්නේ minus oxygen state. electron එක carry කරනවා oxygen state contribution -1. balance නේ. හරි. charge balancing. charge කියන්නේ උඩ තියෙන balance කරන්න. මෙතන +2, මෙතන -2. +2 -2 is 0. That is balanced. No need of using H pluses. Hurry. Right? Right. So this equation is balanced. Or make them opposite. Hurry. Hurry. Right? ළමයි ඔය දෙකම අපි කතා කරේ ළමයි when right a cell is at work. When a cell is at work, that is when one half cell oxidizes and another half cell reduces. හරි. සමහරක් වෙලාවට දිනන ළමයි හිතන්න ඔයාගේ මෙහෙම මේව සෙට් කරලා නැහැ. connect කරලා නැහැ. we call such a situation as an open circuit situation. දැන් උදාහරණයක් ගත්තොත් ඔයා කඩේට ගිහිල්ලා බැටරියක් කිල්ලුවට පස්සේ කඩේට ගිහිල්ලා බැටරියක් කිල්ලුවා. බැටරියක් කිල්ලුවට පස්සේ හරි ඔයාට බැටරියක් දෙනවා. ඒ දෙන බැටරියේ කැතෝඩ් එක ඇනෝඩ් එක කනෙක්ට් කරලා නැහැ නේ. පොසිටිව් එක මිලෙන් කොට කනෙක්ට් කරලා දෙන්නේ බැටරිය නේද? හරි. මුදලාලිගෙන් බැටරිය ලෝසේ ඌ වෙලා මේ වයර් කැල්ලක් කරලා වෙත් කනෙක්ට් කළා. ඒක දෙන්නේ නැහැ නේ. හරි. මුදලාල් දෙන බැටරියේ කැතෝඩ් එක ඇනෝඩ් එක දැන් පොසිටිව් එක මිලෙන් නෙගටිව් මිලෙන් කනෙක්ට් කරලා නැහැ. This is referred to as open circuit situation. Just the battery is there. No circuit there, just the battery is there. Right? In such a situation, which is referred to as an open circuit situation, no current flow through the circuit. දැන් මෙහෙම නක් කමන්නේ. දැන් මෙහෙම දිනනවා. අනිත් පැත්තේ open circuit. So no current flow. No flow of electrons. එතකොට මෙහෙට යනවද? මෙහෙට යනවද කියලා කතාවක් නැහැ මේකේ. ඒතකොට ඉලෙක්ට්‍රෝන මෙහෙට යන්නෙත් නැහැ, මෙහෙට යන්නෙත් නැහැ. එහෙම කිව්වොත් නේද? ඒතකොට කියන්නේ oxidation එක වෙන half cell එකකුත් නැහැ, reduction වෙන half cell එකකුත් නැහැ. That is what happens when a circuit is open. ඉස්සෙල්ලා වෙලාවේ when a circuit is closed. Only when a circuit is closed, right? Only the reduction reaction happens at the cathode, only the oxidation reaction happens at the anode. When the circuit is closed. But if the circuit is open like this, you can't say only the oxidation happens at the cathode, sorry, anode. You can't say only the reduction happens at the cathode. එහෙම කියන්න බෑ. ඒ ඉලෙක්ට්‍රෝන්ස් යන බව පේන්නේ නැහැ නේද? අන්න ඒ වගේ වෙලාවට අපි කියනවා ඕකට දෙකම වෙනවා කියලා. දෙකම වෙනවා. ඒ කියන්නේ සරලව මෙහෙමයි. අර මැග්නීසියම් වගේ විතර ඉන්නවනම් හරි මැග්නීසියම් 2+ උත් වෙනවා. රිලීස් වෙනවා. හරි? මැග්නීසියම් 2+ වල මෙහෙම රිලීස් වෙද්දි ළමයි දැන් අපි මෙටල් එකක් ගත්තොත් මම මෙතනින්ම කතා කරන්න. හරි? මැග්නීසියම් එක මැග්නීසියම් 2+ වල රිලීස් වුණොත් හරිද? So this is a metallic lattice now. Metallic lattice means metal cations dip in a sea of electrons. හරිද? magnesium 2+ වල release වුණොත් now you have more electrons at the right metal solid. හරි. සමානව තිබ්බේ magnesium ions මෙතනට ආවම electrons වැඩි. ඒක මොකද වෙන්නේ? ආයතනයේ magnesium ions now this term will get some negative charge. As now you are with more electrons as plus charges came to the solution. ඒක මොකද වෙන්නේ? ඒක ආයතනයක් මේක content try කරමු. right? එතකොට මේක open circuit නම් ඔය නැත්තක් තියෙන්නේ. oxidize උත් වෙනවා. this magnesium කියන්නේ oxidize උත් වෙනවා. magnesium 2 plus උත් වෙනවා. magnesium 2 plus magnesium උත් වෙනවා. no net reduction no net oxidation. ඒකනේ මෙතනින් electrons එළියටවත් ඇතුළටවත් යන්නේ නැත්. oxidation එකේදී electrons release වෙනවා. ඒ ටිකම accept කරලා reduction වෙනවා. එතකොට මේ terminal එකේ එළියට electrons යන්නවත් වෙන්නවත් උත් වෙනවා. That is what happens when open circuit is there. Both the reduction and oxidation occurs. But if the circuit is closed like this, only one thing will occur. At this terminal, definitely electrons are going. That means only the oxidation should occur. At this terminal, the electrons are definitely coming. Only reduction should occur. If the circuit is closed like this, open වුණා නම් electrons කොහෙද යන්නේ? right? එහෙනම් ඉතින් මේක ඇතුලෙන් electrons එළියට එනවා කියලා කියන්න බෑ. මෙතනට electrons ඇතුලට එනවා කියලා කියන්න බෑ. එහෙනම් ඉතින් ඇතුලේම electrons එළියට එනවා, ඇතුලට යනවා. මේ net process එකක් නැහැ. Oxidation occurs, reduction will occur, both happens. But not there is no net reduction or oxidation. Right? So that is the open circuit situation. So let's come up with that as well. Right? At equilibrium, this is referred to as the equilibrium. Oxidation occurs, reduction occurs, and both occurs with the same rate. That is why no net releasement of electrons or no net absorption of electrons. එක්කෙනෙක් oxidation electrons they are release කරනවා. ඒ වගේම reduction වෙද්දී electrons they accept කරනවා. Both things occur with the same rate. That is why you won't see any kind of electrons going out from there or coming towards there. Right? That is an equilibrium situation. That is an equilibrium situation. Tim කියන්නේ ඒක. හරි? Process දෙකම වෙනවා with same rates. One can say forward reaction and reverse reaction. Those are carrying this that relationship නේ. මේක forward නම් ඒකෙම reverse එකනේ මේ තියෙන්නේ. මේක forward නම් ඒකෙම reverse එක තමයි මේ තියෙන්නේ. නේ? මේක forward නම් the two things are the reactants. Right? In this case those are the products. Right? So මේ reactions දෙකම වෙනවා same rate වලින්. That is referred to as equilibrium situation. Forward and reverse reaction both occurs with the same rate. So let's try to come up with the change, try to represent the change there at the equilibrium. So at the equilibrium, normally we are referring to an open circuit situation, right? Open circuit के लिए आया ना? तो मैं oxidation या तो reduction या लियो ना? हर ए लाटा හැබැයි ළමයි දැන් අපි මේක ලියද්දි අපි මේක represent කරද්දි we have a convention like the sign convention in optics or optics sign convention එකක් තිබ්බේ නේ රාවණ කියන්නේ මොකද්ද මිරේකින් නේද මිරේකින් එළිය මේ පැත්තට යනකොට මොකද්ද මිරේකින් යනවා නම් නේද පොසිටිව් එකක් දිනනවා මිරේකට එනවා නම් මතකද නැහැ sign convention ඒ වගේ මේකත් තියෙන sign convention එක මේකත් තියෙන convention එක මේක අපි කියනවා if you are writing the change for electrode at equilibrium we are supposed to come up with the reduction reaction as the forward reaction. The equilibrium එක ලියනකොට මේක forward reaction විදිහට ලියන්න පුළුවන් මේක විදිහට ලියන්න පුළුවන් forward reaction එක. ඒ කියන්නේ මම සරලව කිව්වොත් කාටට ලියන්න පුළුවන් මෙහෙම ලියන්න පුළුවන්. කාටට ලියන්න පුළුවන් 2 of electrons plus magnitude plus එක්ක මේ කාටට මෙහෙම represent කරන්න පුළුවන්. equilibrium situation එක. කාටට මෙහෙම represent කරන්න පුළුවන්. Here the forward reaction is reduction reaction. Here the forward reaction is oxidation reaction. Right? So what we prefer is this one. This is the convention, right? If you are writing equilibrium reaction, definitely you have to write the reduction reaction as the forward, right? That is how we are supposed to represent the change in electrode at equilibrium. So magnesium 2 plus AQ, double arrow, magnesium solid, 2 electrons IPA. Equilibrium DNA විදිහට. හරිද? Right. We have the reduction reaction as the forward reaction. හරි මේක කම්ප්ලීට් කරගන්නවා. පින්තූර ඇඳලා. तो मैग्नीशियम නැත්තම් ඕන කොපර් නම් කොපර් විදිහට ලියන්න. කොපර් ඊට කොපර් රිප්ලේස් වෙනවා. නිකල් නම් ඕන මෙටල් එකකට ඔය වගේ ඇඩ් කරන්න පුළුවන්. No need of drawing these things, right? That is how a metal ion electrode behave. Right. So I have drawn some standard electrodes, right? That is why it is necessary to come up with the 1 mole situation. If just a magnesium 2 plus electrode is concerned, no need of writing the concentration, right? As long as it is a standard electrode, definitely you have to come up with the concentrations as well. Standard situations, right? Hard. අපි ඔය විදිහටම මෙයාගෙන කතා කරමුද? How this gas electrode, H plus H2 electrode is supposed to behave when it is acting as a cathode, when it is acting as an anode, as well as when the circuit is open, right? So as a cathode, can't you write ඔයාලා ලියනවද? තනියම ලියන්න try කරනවද? As an anode, and when the circuit is open at equilibrium. මොකද වෙන්නේ ළමයි? කැතෝඩ් එකක් කියලා කියන්නේ රිඩක්ෂන් නේ, රෙඩ් කැට් නේ. Again you have to arrange these two guys, right? Where a reduction could occur. So this guy's oxygen state is +1. මෙයා කීයද බිඳුවයි නේ oxygen state එක. It's a reverse couple. So you have to arrange in such a manner where the oxygen state decreases when going from reactant products for the reduction half reaction. So now it should be going from H plus AQ to H2 gas. Right? So balance can't. When balancing, these 4 steps should be followed. Alright? So the first step is what? Balancing redox atom. අමතක කරන්න එපා. මෙතන redox atom කීයද? hydrogen එක්කෙනයි hydrogen දෙන්නෙක් ඉන්නවා. So you have to count it 2 here. That's the first thing to do. Then second thing, balancing oxygen states. So the plus one, such two guys are there, so plus 2 here. This is 0. To balance oxygen states, you need to come up with some minus 2 here. So the 2 electrons should be added there. Alright? දැන් මේ විදිහකට දාන කියලා යන්න ඕනේ නැහැ උදේ අන්තිමට මේ ඉක්වේෂන් දුන්නා මැදි හොඳේ මම මේ බැලන්ස් කරන හැටි වඩු ගන්නවා හරි ඒක අමතක කට්ටියට හරිද මේ යන්න ඕනේ නැහැ විදිහින් බ්‍රැකට්ස් වල යන්න ඕනේ you need to come up with the physical state right now these ones at the bottom so say balancing charges එකෙන් උඩ තියෙන බැලන්ස් කරියෝ -2 +2 0 charges are balanced shape then things are balanced, huh? Hydrogen balance. That is how we are supposed to write the half reaction when this H plus H2 electrode acting as a cathode. Right? Anode depth omaliyan. Cool. Anode deliyana na? You have to arrange these two guys, the redox couple, in a manner where the oxygen state increases when going from reactant to products. Because it's oxidation at the anode. Leave here. So oxidation වැඩි වෙන පැත්තට. So 0 to plus 1. හරි ලේසි. Species with the low oxygen state going towards the species with the high oxygen state. That is what it means as an oxidation. Right? हर ये balance करो balancing steps ही follow करा balance the redox atom so 2 hydrogens are there so you need 2 here balancing the oxygen states so 0 here you have +1 into 2 +2 so to balance the oxygen states you need to come up with some -2 here. That means 2 electrons should be added to each side. Right? Alright, then the charges +2 -2 is 0. +2 -2 is 0. This is also 0. Charge that is balanced, no need of using medium. Finally, the hydrogen oxygen balancing. So you have 2 hydrogens as well as here. At this side, so hydrogens are also balanced, so you no need of using H2O, right? So that is how we are supposed to come up with the half reaction of H plus H2 electrode when it is behaving as an anode. Definitely in a closed circuit situation, right? Okay. Alright. Equilibrium na? So you have to write the redox reaction. So you have to write the equilibrium reaction, the double arrow reaction. There your forward reaction is represented in the reduction reaction, right? Okay. So this is the reduction reaction. So it should be written like that. Forward thing should be the reduction. මේ ලයිමේ reaction උඩින් red ox ඕලියන් නැහැ හොදේ. එහෙම ලියන්නේ නැහැ විභාගෙදී හරි මම මෙයාට ඔළුවට යන්න ඕන සයිකල් ලිව්වේ විභාගෙ ලියන්න එපා red ox එහෙම ඕනේ. හරි හරි වැලි right this is the second cell type. දැන් පොඩ්ඩක් තා පොඩි දෙයක් කතා කරමු මේ here the platinum is used. What is the usage of this platinum when thinking of gas electrodes? Same kind of thing will be used at the redox electrodes as well, the next electrode type, right? Okay, let's discuss about why we use this platinum here. Any platinum electrode use karan. So sometimes they will ask that the usage of platinum there, right? So what are the usages? What is the use of platinum for these gas electrodes as well as for the redox electrodes? So, yeah, the next slide, right? Okay. platinum use කරන මොකටද? කාටද මතකද? එනිම non reactive කියන නෙවෙයි. හරි non reactive වෙන එක හොඳයි. ඉතින් ඒක හරි. ගැටලුවක් නැහැ non reactive එක හරි. නමුත් මේ non react that is not the use. ඒක use එක නෙවෙයි. non reactive වෙන එක ඉතින් හොඳයි. ඉතින් අර යා අනික් කට්ටියට මේ බාධා කරන්නේ නැහැ. Right? No interference. No other reactions occur. But platinum use කරන non reactive නිසා නෙමෙයි මෙතනදී. ඒක නෙමෙයි use එක. Platinum is used to connect this half cell to the external circuit. ළමයි දැන් මෙහෙමයි කතාව. දැන් half cell එක කියන්නේ H+H2. දැන් මේක ඇවිල්ලා මේ හරි half cell concept එක ඇවිල්ලා half cell එක කියලා කියන්නේ H+H2. H+ gas sorry H+ equals and H2 gas. ඔක තමයි half cell කියන්නේ. හරි ඒක මේ physical nature එක තමයි මේ කතා කරමින් ඉන්නේ අපි. හරි? Now the idea is if you have H+ and H2 right which are actually in contact, right? We say it's a half cell. Or if you are with a magnesium and a magnesium 2+ aqueous solution in contact, it is a half cell. දැන් මේ shape එකම දෙන්න ඕනේ නැහැ කවුරුර මේව දානවා. හරි මේ බෝලයක් අස්සට හරි මේ වගේ තරුවක් වගේ එකක් මොකක් තරුවක් වගේ magnesium එකක් මොකක් හරි. හරි magnesium base here. This is also half cell. Hurry. If you have a magnesium solid in contact with magnesium 2+ aqueous, it's half cell. Magnesium 2+ half cell. Electro. හරිද? එතකොට ඒ කියන්නේ if you have some දැන් මෙහෙම විතර අතර යොතින් අර ඒ කියන්නේ ඔයාගේ H2 gas එකක් තියෙනවා නම් හරි the concept of half cell is there. half cell කියන idea එක නම් තියෙනවා. හරි H+H2 in contact. හැබැයි මේක cell එකකට use කරනකොට හරිද? now we need to connect this one to the external circuit. එයා cell එකකට වැඩ කරද්දී මේක external circuit එකට connect කරනවා. exactly මේක external circuit එකට connect කරන්න නම් මොකක්ද දෙන්න ඕනේ? there should be terminal. terminal එකක් තියෙනවා external circuit එකට. so you should have a metal solid there, solid metal as a terminal. So that is what platinum do. It is used to connect the half cell to the external circuit, acting as the metal terminal, metal solid. හරි correct තමයි එක දෙයක් කියා කරන්න. හරි one usage right connect the half cell to external circuit. ඒක usage දෙකක් තියෙනවා. connect the half cell to the external circuit is one use. හරිද? මොකද මෙතන මෙටල් එකක් නැහැ නේ. මෙතන half cell components ලගේ මෙටල් එකක් නැහැ. half cell එකේ redox couple එකේ විදිහට මෙටල් එකක් නැහැ ඔයාට. metal solid එකක්. එහෙනම් අනිවාර්යෙන් terminal එකක් විදිහට ඔයාට externally කෙනෙක්ව මෙන්න එළියෙන් කෙනෙක්ව introduce කරන්න වෙනවා. ඒකට තමයි platinum use වෙන්නේ. නැත්තම් ඔයාට terminal එකක් නැහැ. external circuit එකක්. හරි. අනිත් usage එක තමයි it will help the electron transfer process. For reduction, for oxidation, electrons should transfer between the H+ and the H2. So platinum is acting as the surface, kind of a catalytic surface, right, to facilitate the electron exchange process. දැන් මේක එහෙම අවුලක් නැහැ. ඔයාට metal surface දිනන යාට වැඩි කරගන්න. ඉලෙක්ට්‍රෝන එක්ස්චේන්ජ් කරගන්න. බට් මෙටල් සර්විස් සොලිඩ් සර්විස් එක නැති වුණාම මේකට හෙල්ප් කරන කැටලිටික් සර්විස් එක තමයි පාවිච්චි වෙන්නේ. ඔය යූසේජ් දෙක තියෙනවා right. Acting as a, those are two usages. Acting as a catalytic surface to electron exchange, for electron exchange. तो वजह तो मैं क्या करूँ? Current the half cell to external circuit, acting as a catalytic surface for electron exchange. Sorry? Hard. This is usage of platinum in these half cells. Platinum is not going to oxidize or reduce. It will be used to connect the half cell to the external circuit, and it will be used as a catalytic surface for the electron exchange process, right? Right. අපි කතා කරමු the third half cell type again. Altogether 4 kinds of half cells in our syllabus, right? Let's discuss about the third type of half cells. Or third type. Redox electrodes, redox half cells. ඔක්කොම half cell වල ඉතින් redox process තමයි වෙන්නේ. හැබැයි especially redox electrode කියලා දාපු half cell type එකක් තියෙනවා. So the specialty with redox electrodes is actually both the redox couple there appear as aqueous solutions, right? In gas electrodes, definitely one of the redox couple should come up as a gas. In metal ion electrode, the redox couple should represent a metal and a metal ion aqueous solution. But when it comes to redox electrodes, the specialty there is both the redox couple appear as aqueous solutions. If you need some example, Fe2 plus Fe3 plus electrode, the higher oxidation state Fe3 plus, the low oxidation state Fe2 plus, both appear as aqueous solutions. Both appear in the same aqueous solution. Fe2 plus Aq, Fe3 plus Aq. This Fe2 plus Fe3 plus electrode, that is an example for a redox electrode. If you need more, Mn2 plus MnO4 minus electrode, that redox couple. So basically, any half reaction you have learned in inorganic chemistry or maybe in chemical calculations can be used as an electrode. ඔයා inorganic වල ඉගෙන ගත්ත ඕනම half reaction එකක් ඕනම reduction reaction එක oxidation reaction එක half cell එකක use කරන්න පුළුවන්. Right? The MnO4 minus Mn2 plus, another half reaction you have learned in needles in inorganic chemistry as well as calculations. Dichromate Cr3 plus in acidic medium, another example for a redox electrode. Tin 2 plus tin 4 plus. Acidic medium basic medium dichromate and chromate chromate Cr3 plus ये gas electrode use then me gas electrode gas H2 electrode use example if you are to right if you think of this reaction, magnesium reacting with HCl, you put some magnesium piece to HCl solution. A redox reaction will occur, spontaneous redox reaction will occur. What is the reaction? Metal with an acid will react to form the salt and H2. Magnesium chloride and H2. Actually there what happens? magnesium converted into magnesium 2 plus when forming the magnesium chloride, and HCl, there the H plus was there, converted into H2. So there redox process is there, oxidation and reduction is there. So you can use that redox reaction to construct a cell where you are with magnesium 2 plus half cell and H plus H2 half cell. ඔයා කතා කරපු ඉනෝගනික් කතා කරන ඕනම රෙඩොක්ස් රියැක්ෂන් එකක් ඔයාට සෙල් එකක් කන්ස්ට්‍රක්ට් කරන්න යූස් කරන්න පුළුවන්. ඕන ස්පොන්ටේනියස් රියැක්ෂන් එක. Fe2+ KMnO4. පුළුවන්. There you will obtain Fe2+ half cell and the MnO4 minus Mn2+ half cell. If you are trying to construct a cell from that redox reaction, right? එහෙම කතාව. ඉතින් ඔයාට ඕනම ඕගනික් ඉනෝගනික් වල ඉගෙන ගත්ත redox reaction එක cell එක construct කරන්න use කරන්න පුළුවන්. Then the automate types of these 4 types of half cells will be observed. Alright, so let's again come up with the redox half electrode, right? So I'll come up with some example there. අර resource book එකේ දෙන example එක මම යන්නම්. සාමාන්‍ය අපි ඔක්කට කතා කරන්නේ මේ වගේ half cell එක Fe2+ Fe3+ මේ හැබැයි අරවත් පුළුවන් MnO4 minus Mn2+. We'll come up with the standard. So this is the general form, right? Both the guys appear as ions, aqueous ions. So Fe2+ are the same solution, na? That is how redox half shell looks like, redox electrode looks like. Both are aqueous ions appearing in the same aqueous solution. Again, now you have a problem. How to connect this half cell to the external circuit? No solid terminal is appearing, no? With the two redox couple, no solid terminal is appearing. So that definitely we have to get the help of platinum solid to connect this redox couple or this half cell to the external circuit. So we need the use of platinum surface. So that will facilitate the electron exchange as well. This is how a redox half cell looks like. Platinum surface අනිවාර්යෙන් දාන්න වෙනවා. හරි? ඒකෙත් තෝරන යූසේජ් ටික ලියා ගන්න. අර යූසේජ් එක තමයි හරි. ආයෙත් තෝරන ලියන්න නැත්නම් ලියු කමන්නේ එකම යූසේජ් තියෙනවා. Right? Hari, this is how a redox electrode looks like. So let's come up with the equations as well. Me the equation live as anode, as a cathode, you'll down. No need of looking at the board, just right. As a cathode, you have to arrange the two in a way, right, where the oxygen state reduces. Sorry. So you start with the high oxygen state, and at the product side you have to write the low oxygen state out of the two redox couple, right? You have to start with the high oxygen state, Fe3+, end with the low oxygen state. Use the redox balancing techniques, right? Atom balancing, 1 balanced. Oxygen state balancing, +3, +2. So you need some 1 electron here, -1 here to balance the oxygen state. So 1 electron. So charge balancing, charge is balanced. As an anode, oxygen state has to be increased. Atom balancing is done, then the oxygen state balancing. Come up with one electron here. Very balanced, no? If it is used in an open circuit, so forward reaction should be the reduction reaction. It should be double layer reaction, right? Now it is must to write these physical states, huh? If you are writing these reactions without physical states, you won't get marks. Alright. Sure. Let's come up with the fourth type. Right, metal insoluble salt electrodes. Right. So here the redox couple should contain a metal and a metal insoluble salt. Metal insoluble salt means a precipitate. Metal insoluble salt is a precipitate. And metal precipitate like silver chloride electrodes. Those are the, we have two most famous two electrodes, right, from this type, right. One is the silver chloride electrode. Silver chloride is insoluble in water, right. Another one is mercury chloride electrode, right, Hg2Cl2. So tell me another example other than those two, other than the two famous stuff. Tell me another example for a metal ion electrode. Oh, silver, sorry, aluminium hydroxide. You know most of the precipitates, no? Magnesium hydroxide, magnesium oxide, zinc oxide. හරි ළමයි ඇක්ටිවිටි සීරීස් එකේ මැග්නීසියම්ට පස්සේ තියෙන මෙටල්ස් ලයි කිසිම ඔක්සයිඩ් එකක් වෝටර් වල ඩිසෝල්ව් වෙන්නේ නැහැ. ඇලුමිනියම් ඔක්සයිඩ්. ඇලුමිනියම් ගිනේද? අර ඔක්සයිඩ් ලේ එක හැදලා ඇලුමිනියම් ගිනේද? කොරෝෂන් එක නවතිනවා. Aluminium is protected by the formation of the oxide layer. අපි පොඩි කාලේ ඉගෙන ගන්න. ඒක වතුරේ දී වෙන්නේ නැහැ. That is why we are able to use the aluminium containers in cooking purposes. හරිද? ඒතර ඒ වගේ මේ metals වල activities එකේ aluminium magnesium ගෙන් පිටිපස්සේ තියෙන metals වල oxides වතුර දී වෙන්නේ නැහැ. zinc oxide electrode. Metal insoluble salt. The hydroxides. Right, one can say lead chloride electrode. Hoydi? මොකද මෙටල් එක අනිවාර්යෙන් කම්පවුන්ඩ් එකක් හදි අනිවාර්යෙන් මෙයා ඉන්නේ පොසිටිව් ඔක්සිජන් ස්ටේට් එකක. මෙටල්ස් වල නෙගටිව් ඔක්සිජන් ස්ටේට් කතා කරන්නේ නේ. ඒතර අනිවාර්යෙන් මෙටල් එකේ ඉන්නේ 0 ඔක්සිජන් ස්ටේට් එක. කම්පවුන්ඩ් එක හදලා අනිවාර්යෙන් පොසිටිව් ඔක්සිජන් ස්ටේට් එකක ඉන්නේ. ඉන්සොලියබල් කම්පවුන්ඩ්ස් ගත්තා නම් වැඩේ හරි. ඕන තරම් හරි ඕක දැක්කකයි බය වෙන්න එපා. මෙටල් එකකුයි insoluble salt එකකුනේ සෙට්ලා දින වැඩේට අනිවාර්යෙන් there is a kind of a metal insoluble salt electrode. metal එකේ precipitate එකකුනේ සෙට්ලා දින වැඩේ හරි. silver chromate electrode ඔය තියෙන්නේ අම්මා. බේරියම් සල්ෆේට් ඉලෙක්ට්‍රෝඩ් ලියන්න පුළුවන් උතර. විභාගෙ මොනවයිද දන්නේ නැහැ. වචන පුරුදු වෙලා ඉන්න. බය වෙන්න ඉන්න එච්චරයි. බය වෙන්න එපා. හරි. බේරියම් සල්ෆේට් ඉලෙක්ට්‍රෝඩ්. Barium is a metal. Barium sulfate is kind of precipitate. So metal insoluble salt electrode. Barium sulfate is insoluble salt precipitate එකේ. හරි. එතකොට මේ kind එකේ famous දෙන්නෙක් කියලා මම කිව්වනේ. Silicon chloride electrode and the mercury chloride electrode. Right. So those are the two pictures we are going to draw here. අපි කතා කරන pictures ඔය දෙක. හරි. අනිත් ඕනෑම විභාගෙදී අහන්න පුළුවන්. විභාගෙදී ඇහිලක් තියෙනවා. සිංක් ඔක්සයිඩ් එහෙම අහලක් තියෙනවා. හරි ඕනක් ඇහෙන්න පුළුවන්. මොකක්ලාට මේ જાතියේ questions අහනවා වැඩි. හරි. metal insoluble salt electrodes පැත්තට යනවා වැඩි මේ පාස් වෙස් කරන theory ටික වැඩිපුර දිනන මේ જાතියේ questions. හරි. Right. So let's come up with the two famous electrodes, right? One is referred to as the AgC electrode. One of the redox couple is as a metal, the other one is as a precipitate, insoluble salt. හරි. ඒතර මේකේ ළමයි අර metal insoluble salt electrodes ගතට පස්සේ ඒක අර standard නැද්ද කියලා හැම ලොකු ප්‍රශ්නයක් නැහැ. හරිද? ඒ කියන්නේ standard නැද්ද කියලා ප්‍රශ්නයක් එන්නේ when you are with a gas or when you are with a aqueous solution. When you are with a aqueous solution, standard states are defined as 1 mole concentration solution. When you are with gases, the standard state is referred to as 1 atm. ඒ කියන්නේ 1 atm කියන්නේ concentration තමයි. gas එක pressure එක කියන්නේ concentration තමයි. P is equal to CRT or C is equal to PORT. හරි. concentration වෙනස් වෙන තමයි ප්‍රශ්නේ තියෙන්නේ. But when it comes to solids, their concentrations are constants. Solid එක අතර concentration වෙනස් වෙන්නේ නැහැ. Concentration means the number of particles in unit volume. Particles in unit volume. Solid එකේ වෙනස් වෙන්නේ නැහැ. Right? Some constant arrangement of matter. Right? So ඒ නිසා මේ solid තියෙනකොට concentration වෙනස් වෙන්නේ නැහැ. ඒක නිසා මේ standard නැද්ද කියලා කතාවක් නැහැ මේකේ. මේකම standard AgC electrode කියලා ලියුවත් එකයි එහෙම නිකන් AgC electrode කියලා එකයි තමයි තියෙන්නේ. සන්න නැහැ. සාමාන්‍යයෙන් අර ලියන්නම් වල ලියද්දි ලියන standard ගාලා දාලා ලියනවා. හැබැයි ඒකේ standard නැහැ කියලා දෙයක් නැහැ. As long as you are maintaining the temperature 25 Celsius, nothing to do with the physical states. Right? Standard නැහැ කියලා වෙනස් වෙන්න පුළුවන් physical state එකත් එක්ක විතරයි. Sorry මේ temperature එකත් එක්ක විතරයි. මේ නැත්තම් ඉතින් අර ලියද්දි ඉතින් එහෙම වෙනසක් නැහැ. හරි. හරි එතකොට මේ AgC electrode මේ වගේ දින්නේ පොඩි පිච් එක වාල් දැනගන්න ඕනේ. හරි. මේ දින්නේ නැති මේ ටෙස්ට් ටියුබ් එකක් ඔයයක් තියෙනවා. පොඩි ග්ලාස් ටියුබ් එකක්. හරිද? මෙහෙම ක්ලෝස් කරලා තියෙන ටියුබ් එක. හරිද? right. ඒකෙ මෙන්න මෙහෙම සිල්වර් වයර් එකක් දාලා තියෙනවා. සිල්වර් solid. සිල්වර් solid එකක් තියෙනවා. සිල්වර් වයර් කිව්වත් කමන්නේ. ඒකට paste කරලා තියෙනවා silver chloride salt. And those were dipped in a saturated solution for AgCl. Lamai, if you are with a precipitate appearing with a solution, definitely the solution should be saturated. KSP stuff will learn them. KSP දේවල් හරි KSP කියලා එකක් තියෙනවනේ. ඒ කියන්නේ මේ if you are with a solid precipitate appearing with a aqueous solution, definitely the aqueous solution should be saturated, right? So here we are using KCl aqueous solution saturated with your precipitate. If you are with a aqueous solution with a precipitate, definitely that solution should be saturated with the corresponding precipitate, right? Okay, and here this is what we use to connect this half cell to the external circuit, right? So this is the connecting method. One can say it is separate. This semi-permeable membrane. One can say membrane. No, not to the external circuit. This is used to connect to the external circuit. This is used to connect to the other half cell. Cell එකක් හදලා ළමයි half cells දෙකක් connect වෙන්න බෑ. ඒකට මේක use කරන්නේ අනිත් half cell එක connect කරන්න. මෙතන use කරන්නේ external circuit එක, right? Normally when metal insulated electrodes are used, we are not supposed to use soul bridges. Soul bridge use කරන්න නැහැ සාමාන්‍යයෙන්. හරි? යතන soul bridge එකම set කරලා දින half cells එක. දැන් මේකත් use කරන සාමාන්‍ය whole soul bridge එක use වෙන්නේ නැහැ. දැන් මෙයාව connect කරන්න ඕන නම් මේ half cell එකට මොකද කරන්නේ? උස්සන් ගියා මෙතනින් dip කරා. දැන් මෙහෙම මෙයා හිටනවා මෙහෙම ගියා. මේක ඉතින් අර membrane මේ කෑල්ල. මේකල ගිය membrane කියලා. මේ උඩ කෑල්ල එහෙම දිනනවා. මෙයා මේ වගේ මේ size එකක් තියෙනවා. සිලිසිලියම් ඩිටෙක්ටර් එකේ මේ වගේ පොඩි. අරන් ගිහලා සෙට් කරන්න ඕන නම් ගිහලා. දැන්. දැන් සෙල් එක. These two things will connect to the external circuit. But this is the probe which will connect to the other half cell. මේ දානවා ඩිප් කරලා තියෙනවා. හරි. හොඳට තමයි. So this is used to separate or glass membrane or kind of a membrane we used to connect to the other half cell, right? This is the apparatus. This is how it looks like, and let's come up with the half equations as well. Half equation theorem as a cathode. As an anode. At the equilibrium. Right. දැන් ඔයාලා පරිස්සමෙන් ලියන්න ඕනේ මේක හරි. ඇයි එහෙම කියන්නේ? මේකේ redox couple එක සිල්වයි සිල්ල ප්ලසුයි නෙමෙයි. The redox couple is Sil and Sil chloride, right? So you have to place this redox couple, right, accordingly, right? You have to place this redox couple accordingly as a reduction reaction as well as a oxidation reaction. Hurry, බලමු place කරන්න කියලා. If it is behaving as a cathode, reduction should occur there. So you have to place the two guys in a manner where the oxygen state should decrease when going from reactant to products. Hurry, again you have started the AgCl. At the product side you have to put the Ag. So plus 1 goes to 0. Right? Now you have to balance the stuff. Then balance करना है. कौन balance करना? First thing, atom balancing. इकाई इकाई 1 1. Redox atom balancing done. Then oxygen state balancing. +1 0. So to balance oxygen states, we need some -1 here. So that means you need some electron there. Alright. Third step, charge balancing. So you have -1 charge here, but not here. Some -1 charge is here at this side, but not here. So some -1 is needed for the other side as well, right? But you see, here you have some Cl- as well. So you can do the charge balancing as well as the rest of the atom balancing by placing some Cl- here. Or make your acidic medium, basic medium kata onne la make. So you can't use H plus or H minus, but you have some Cl- to use for the balancing. So if you have to put some Cl- here, then both the steps are done. Charge balancing and as well as the rest of the atom balancing. Alright. That's a reduction ratio. And on oxidation first place the redox couple right in a manner where the oxygen state should increase. So that should be Ag solid to AgCl. Don't write it as Ag to Ag plus, right? This is not a metal ion electrode. This is all about metal insoluble sort electrode. So the redox couple should be there, right? Redox couple should be represented at the half reaction as well, right? So 0 here, +1 here. So some electron is needed to this side. So that some Cl- should be added to this side. Right? So you can write the equilibrium situation as well, right? Take in the reduction reaction as a forward reaction, right? For the double reaction, right? Don't forget to write the physical states, right? Those are kind of a must, right? Alright. Tiumai seriously recorded it already. Hurry. Shape it. අපි අනිත් ටෙට්‍රා ටයිප් එකත් हम බලමුද මෙටල් ඉන්සර්ට් ටෙට්‍රෝඩ්ස් වල පාර්ට් ටයිප්ස් දෙකක් තියෙනවා. ඒ කියන්නේ මේජර් ජාති දෙකක් තියෙනවා. පාට සිලිකොරයිඩ් ටෙට්‍රෝඩ් එකයි mercury chloride ටෙට්‍රෝඩ් එක කියලා. calamine ටෙට්‍රෝඩ්, right? We'll discuss about that thing as well. More types are there, but these are the two famous types, right? Most commonly used types, right? mercury chloride ටෙට්‍රෝඩ් එක. Right. I'll write it here. Right, 4 degrees possibly. Another metal electrode. Sorry, metal insoluble, right? Right. So now we are going to discuss about calomel electrode. Right, which is also known as mercury chloride electrode. Right, for the calomel electrode, the redox pair is coming with the mercury and Hg2Cl2. Right. So first of all, let's see how the apparatus looks like. Right. Basically, the apparatus looks like a jug එකක් වගේ හරි. jug එකක apparatus එක තියෙන්නේ හරි. See. අර මේ jug එකක් වගේ හරි like this. jug kind of apparatus jug එකක් වගේ තියෙන්නේ. හරිද? So කොහොමද මේ වැඩේ තියෙන්නේ? redox couple would appear here. This is mercury. Mercury density is high. Mercury and density of වැඩි. So it should appear at the bottom, which is a liquid. And in contact, you have mercury chloride. අනිවාර්ය redox couple එකේ contact එකේ තියෙන්න ඕන. නැත්නම් මේක කරන්න බෑ. No solid. Pure forms, right? Then definitely you have a aqueous solution. Without aqueous solution, we are not going to discuss about precipitates, no? So this aqueous solution, right, should be saturated to your precipitate. So this is again like there is a KCl aqueous solution, KCl aqueous solution saturated with Hg2Cl2. KCl aqueous solution saturated with Hg2Cl2. Then again we have problem. What is the problem? How to connect this redox couple to the external circuit. Connecting the redox couple to the external circuit. So again we don't have a metal terminal there. There should be metal. Without that you can't do the conductivity. Conduction you can't do. For the conductivity you need a metal terminal. That is not there with any of the redox couple. So that we have to get the help of platinum solid. So platinum solid is used to connect the redox couple or the electrode to the external circuit, and it is used to facilitate the electron exchange between the couple, right? Platinum solid or platinum wire, one can see. And here you have the membrane, quartz membrane, one can see, right, which will be used to connect to the other half cell. This is used to connect to the external circuit, this is used to connect to, like this, no? One thing is used to connect to the external circuit, the membrane is used to connect to the other half cell. Here you had used a salt bridge as a connecting method, but when normally when metal insulated electrodes are used, you are not using salt bridges, right? So membranes are normally used, right? Let's come up with the equations for this one as well. Remember here as well, the redox couple is metal and metal salt, Hg and Hg2Cl2. It is not about Hg and Hg plus, right? It's all about Hg and Hg2Cl2. You have to arrange those two components in increasing order or decreasing order of oxygen states for the anode as well as for the cathode. See how to write the equation there. As a cathode, reduction should occur. That means the oxygen state should decrease when going from reactant products. So here you have the zero oxygen state. Here you have the plus one. So oxygen state reduce now. So you have to start with Hg2, Cl2 solid, and should go towards Hg liquid. Right now? So first thing to do is actually balancing the redox atoms. We'll go balancing the redox atoms. That means you have 2 of mercury here, so you need 2 of them here as well. This is the redox atoms balance. Then balancing oxygen states. So you have plus 2 here. So these 2 chlorines carry minus 2, no? So 2 mercury should carry plus 2. Here 0. So some minus 2 is needed. So you need 2 electrons here. Final charge balancing. Minus 2 appearing at this side. There you should have minus 2 there. So that you have Cls as well. So you can come up with 2 of Cl minuses. You can add the anodic reaction as well, right? Or anodical there. The oxygen state should increase. So first 2D is needed here. Finally, 2 of Cl minuses. For the open circuit situation, it should be the reduction reaction as the forward reaction. of a double layer equation. හරි බෑ අර ප්‍රශ්න තමයි. ඒ කියන්නේ මේ වෙන මෙටල්ස් වලට යන්නේ නැහැ මොකද රියැක්ටිව් කියලා ප්‍රශ්නව ඊට ප්‍රශ්නේ අර ඒක යූසේජ් එක ගන්න මේ යූසේජ් එක කියලා කියන්නේ මෙයාට කරගන්න බැරි වෙච්ච දෙයකට උදව් කිරීමක්. ඒ කියන්නේ අර ඒ යූස් කරන මෙටල් එකට තියෙන්න ඕන ප්‍රොපර්ටි එකක් තමයි ඒවා කියන්නේ. මේ යූස් කරන මෙටල් එකේ තියෙන ප්‍රොපර්ටි එකක් තමයි නන් රියැක්ටිව් නේචර් එක. හැබැයි ඒක යාගේ යූස් එකක් නෙමෙයි. යූස් එක කියන්නේ ඒට්‍රෝඩේ මෙයා කොහොමද හෙල්ප් කරන්නේ කියලා. හෙල්ප් කරන්න නම් එයා කරන්න ඕන ඒට්‍රෝඩේ කරන්න බැරි දේ වලට හෙල්ප් කරනවා. කරන්න බැරි දේ තමයි අර දෙක. එකක් තමයි right gives a help to connect to the external circuit and providing some surface to do the electron exchange, right? Hi shape ne hari එහෙනම් අපි electrode types ගැන පොඩි idea එකක් ගත්තා. බලමු එහෙනම් ඔය electrode set කළා right සෙල් එක කන්ස්ට්‍රක්ට් කරන්න තමයි ඊළඟට තියෙන්නේ. හරි. ඊට කලින් පොඩි ෆැක්ට්ස් එකක් තියෙනවා මේ කතා කරමු. හරි. මේ පොඩ්ඩක් කතා කරලා ඉවරලා කෙලින්ම ක්වෙස්චන් එකකින්ම ජෙනරල් පැටර්න් එකක් කතා කරමු ක්වෙස්චන්ස් අහන පැටර්න් එකක් right. හරි. So let's discuss some facts about the galvanic cells. So galvanic cells means the electrochemical cells, right? These guys, right? These are also referred to as galvanic cells. The simplest electrochemical cells are referred to as galvanic cells. Right? Hard. Few facts we should know. The first thing, cell reaction is a spontaneous reaction. Cell reaction is spontaneous. Spontaneous reaction. Second thing, so what about the delta G and E cell? Right? So these two guys will relate with this equation. If it is not, this is also not standard, right? The G and the E will relate with this equation, right? Here the N means number of electrons exchanged. What is that level? Number of electrons exchanged means what? Right? So when cell process is occurring, at number of reactions electrons exchange. So if you need to have some idea about that thing, this is all about this. Say you are constructing a cell right? Consider a cell constructed with Fe2 plus Fe3 plus electrode and MnO4 minus Mn2 plus electrode. Are these two are redox electrodes, right? Two ions in the aqueous solution. Two ions in the aqueous solution, right? So if you are, so you can think of this kind of a setup, right? Sorry. So I am trying to give you that idea what this N means here. Right? So you have Fe2 plus aqueous and Fe3 plus here. And here you have Mn2 plus and MnO4 minus here. This N means, so if you have to come up with the redox reaction, it looks like this now. Oral reaction. So electron difference there is just one electron. Difference there is just 5 electrons, no? When balancing this equation, this reaction, so we have to balance the electrons, so that we need to multiply this thing with 5, no? Least common multiple is used, no? So here the least common multiple of 1 and 5 is 5. So that least common multiple is the number of electrons exchanged. So this guy has released 5 electrons. This guy has released 5 electrons when converting plus 7 to plus 2. Sorry, when converting plus 2 to plus 3, the 5 of these guys has released 5 electrons, and those 5 has been absorbed by this one to convert it into a plus 2. That is what it has happened, no? 5 of these guys has released 5 of electrons to convert those 5 to 5 of Fe3 pluses. And those 5 electrons have been accepted by MnO4 minus to convert it into a Mn2 plus. That 5 electrons, that exchange 5 electrons is the number of electrons exchanged, alright, which is the least common multiple you used when balancing this one, right? मैं balance करा दी, electron balance करा दी, use करना least common multiple is हमारी आगे इतना number of electrons exchange के लिए, alright? Got the idea? Alright? And F is the Faraday's constant. Constant, which is equal to 96,500 coulombs per mole. One can say 96,500, 96,485. That is the correct value, right? Let's try the correct value. But normally in calculations, we use the 96,500 coulombs per mole. Right? So as this one is spontaneous reaction, delta G naught is minus, it is spontaneous, no? So that this should be positive, because number of electrons used is kind of a positive value. Faraday's constant is always a positive value. So to come up with the minus value here, this thing should be positive. If this one is minus, this minus will give you a positive value. So as this one is negative, as it is spontaneous, you should come up with a positive value for the delta E naught cell, for our galvanic cell, right? Idea is clear? right? Let G naught is negative and inner cell is positive. Next thing, some properties of anode and cathode here. Let's discuss what types of reactions happening at cathode and anode in this case when you are regarding to a electrochemical cell. Right? Let's try to complete this table. Right. Okay. Cathode and anode. Cathode means that is the terminal where the reduction occurs. Anode is the terminal where the oxidation occurs. For any electrochemistry process, that is a lead. Even for electrolytic cells. Cathode can red cation, right? Anode is opposite. That is clear? Right. Then, so when two cells are to be connected like this, right? Cathode prefers to get reduced, anode prefers to get oxidized. That means reduction ability is high with the cathode, reduction ability is low with the anode. That is why it tends to get oxidized. Cells half cells connect කරවස ළමයි. cathode දෙක කියන්නේ reduction එක වෙන terminal එක. anode දෙක කියන්නේ oxidation වෙන half cell එක. cathode එකයි reduction එක සිද්ධ කරන්නේ. Because reduction ability is high with the cathode. Ability එක වැඩි නම් තමයි reduction එක කරන්නේ. As reduction ability is low with the anode, that is why it tends to get oxidized. Reduction ability අඩු නිසා anode එක oxidize වෙන්නේ. Reduction ability වැඩි නිසා cathode එක reduce වෙන්නේ. Right? So when it comes to cathode, it is the terminal with, it is the half cell with greater reduction potential. Potential can just something like ability, potential or කොච්චර potential එකක් තියෙනවද කොච්චර ability එකක් තියෙනවද. Right? So when it comes to anode, it is the one with the lower reduction ability. Reduction potential means kind of reduction ability, measure of reduction ability, keenness towards the reduction. Right? Okay? හරිද? එතකොට potential කියන්නේ අර reduction potential, reaction ability, reaction එක කරන දේ කැමැත්ත. හරි? So cathode is the terminal with the greater reduction ability or greater reduction potential, anode is the terminal with the small reduction potential, relatively lower reduction potential. Right? Science. හරි? කොහොම සයින් ඩිසයිඩ් කරන්නේ? මේක කිසිම දෙයක් කටපාඩම් කරන්න ඕනේ නැහැ ළමයි. No need to memorize. දැන් මෙහෙම වැඩි වෙන්නේ. දැන් ඉලෙක්ට්‍රෝන්ස් කොහේද දාන්නේ? Electron flow is like this නේ. නේද? cathode කියන්නේ sorry පැත්ත මාරුනේ. Electron flow is like this නේ. anode කියන්නේ electrons release කරන terminal එක. cathode කියන්නේ electron accept කරන terminal එක. Right? As we know, this one is a spontaneous process. Electrons are going towards positive one, starting from negative one. Spontaneous දෙයක් නෑ. Spontaneous දෙයක් නෑ. Negative particles යන්නේ negative nature එක වැඩි තැන ඉඳන් අඩු තැනට. දැන් මම මේක කටපාඩම් කරන්න දෙයක් නෑ හොඳේ. ඇයි? E minus කියන ලියාගෙන කරවන්න එහෙමද පේනවනේ. එහෙනම් E minus යන්නේ කොහොමද? negative වෙන positive එකට. negative දේවල් වැඩි තැන ඉඳන් තමයි negative particles negative දේවල් අඩු තැනට යන්නේ. ඇයි මම කියන්නේ මේක ස්පොන්ටේනියස් නිසා. ස්පොන්ටේනියස් කියන්නේ නිකම්ම සිද්ධ වෙන දේ. අපි මුකුත් කරන්න නැතුව නිකම්ම සිද්ධ වෙන දේ. ස්පොන්ටේනියස් නේ කතාව ස්පොන්ටේනියස් නේ. ස්පොන්ටේනියස් නිසා නිකම්ම සිද්ධ වෙන දේ අපි මුකුත් කරන්න ඕනේ නැහැ. එහෙනම් නෙගටිව් පාටිකල්ස් යන්නේ නෙගටිව් නේචර් එක වැඩි දෙන ඉඳන් නෙගටිව් නේචර් අඩු දෙන්නට. ස්පොන්ටේනියස්. මෙතන නෙගටිව් වෙන්න ඕනේ. පොසිටිව් වෙන්න ඕනේ. It's very easy to copy the signs of the cathode and anode. Alright. Wait करना easy. දැන් මම මේක උනේ ඇප්ලයි කරන්න අර electrolysis වලට. ඒක ලියා ගන්න එපා electrolysis කතාව ඒක ලියා ගමු. හරි. මේ electrochemical එක නෙවෙයි ඒක ලියන්න. electrolysis වල මොකද වෙන්නේ? ඔයා තේරෙන්න මතන් කියනවනේ. electrolysis කියන තරත් මම මේක මම ඔයාලට ඇප්ලයි කරොත් electrolysis වලට මම මේ කතාවම කියන්න electrolysis වලත් ඔකම කරන නිසා electrolysis ගත්තොත් non spontaneous මොකද ළමයිට වැඩියෙන් පැටලෙන්නේ ඔය සයින් එක සයින්ස් ටර්මිනල්ස් මොකද මොන ප්‍රොසෙස් එක කිව්වත් cathode න reduction anode නම් oxidation තමයි ඒක වෙනස් වෙන්න බෑ හරි ඕමනේ electrolysis ගත්තොත් ඒ අනිවාර්යෙන් මේකත් යන්න ඕන අර විදිහට නේද reduction කියලා කියන්නේ electrons එනවා oxidation කියන්නේ electron අයින් වෙනවා හරිද non spontaneous නේ ඒකට මේ සාමාන්‍ය වෙන දෙයක් නෙමෙයි මේක power එක දීලා කරන්න ඕනේ වැඩ මේ සාමාන්‍ය වෙන දෙයක් නම් මොකක්ද වෙන්න ඕනේ මේක ඍණ වෙන්න ඕනේ මේක ධන වෙන්න ඕනේ සාමාන්‍ය වෙන දෙයක් නම් මේක පව එක දීලා කරන්න ඕනේ දෙයක් නිකන් වෙන්නේ නැහැ ඒ කියන්නේ මේක පොසිටිව් මේක නෙගටිව් මෙහෙම නිකන් වෙන්නේ නැහනේ පව එක දීලා මේක කරන්න ඕනේ පොසිටිව් තියෙන තැනකින් මේ තවත් පොසිටිව් කරන්න ඊට සයින් කරන්න ඒ ලොජිකල් අයිඩියා තියත් නම් හරිය ලේසි වට සයින්ස් එක හොයාගන්න you have to supply some power na without power this thing won't happen without power electrolysis won't happen so power is needed to this kind of a non-spontaneous process සාමාන්‍ය වෙන්නේ තියක් කරගෙන තමයි ඒක මේ power එක දෙන්න ඕනේ මේ නිකන් සාමාන්‍ය වෙන්නේ නිකන් වෙන එක නෙගටිව් නේචර් එක වැඩි තැන ඉඳන් නෙගටිව් නේචර් අඩු තැනට නෙගටිව් පාටිකල්ස් එන එක මේ සාමාන්‍ය වෙන්නේ නැතිදී නෙගටිව් නේචර් එක අඩු තැන ඉඳන් නෙගටිව් නේචර් එක වැඩි තැනට පොසිටිව් නෙගටිව් පාටිකල්ස් එන එක වෙන්නේ නැති එක ඒක කරන්න power එකක් ඕනේ හරි ඉතින් එහෙම ඉතලා වාට සයින් එක බය නැතුව ෆයිට් කරගන්න පුළුවන් no need to buy hard stuff logically you can do that ක්ලෑසිස් කතා කරද්දී ඔක අපි ටේබල් එක අයිත් ගහන්න right so in electrochemical cells anode is the negative terminal cathode is the positive terminal Faraday constant එක මතක තියාගන්න. මොකද ඒක අවුරුද්දක එක්සෑම් එක දීලා තිබ්බේ නැහැ. සාමාන්‍ය දිනවා. ඔව් ගණන් හදනකොට 9,500 තමයි ගන්න. හරි. මේක 9,500 තමයි ඔයා යූස් කරන්නේ. හරි වැලියු එක මම ලිව්වේ. ගණන් වලට 9,500 කියලා තමයි යූස් කරන්නේ. හරි. ඒක ගානට කැපිලා යන්න යූස් කරන එක. ඒතකොට ෆැඩේස් කොස්සේ සමහර වෙලාවට අවුරුදු වල සර්ට මිස් වෙනවා. ඒ කියන්නේ ප්‍රොසෙස් මිස් වෙන්න පුළුවන්. සාමාන්‍ය ක්වෙස්චන් එක දෙනවා ෆැඩේස් කොස්සේ වැලියු එක. ක්වෙස්චන් එක ළඟ දෙන්නේ. ඒක පේපර් එක උඩින් දින වැලියු ගන්න නෙමෙයි. ක්වෙස්චන් එකත් එක්කම දෙන්නේ. නැත්නම් සමහර වැලියුස් තියෙන උඩින් දින ප්ලාන්ක් කොන්ස්ටන්ට් උඩින් දින පේපර් එක උඩින්මනේ. C වැලියු එක දෙන්නේ පේපර් එක උඩින්ම. අවොගාඩ්‍රෝ කොන්ස්ටන්ට් දෙන්නේ පේපර් එක උඩින්ම. අර එහෙම වෙන වැලියු ගන්න නෙමෙයි 9,500 එක. ඒක ක්වෙස්චන් නම්බර් 7 ළඟ දෙන වැලියු එක. ඒ සාකච්ඡා ප්‍රොසෙස් ලියන්නේ කවදද? ඒක ගාන හදන්න බැරි නෝ. පස්සේ ඉතින් ලියන්න ඕන ගාන හදන්න බැරිනොත් ලකුණු ටික දෙයි එකට. හැබැයි ඊට වඩා වෙන කෙලියක් වෙනවා නේද? ලකුණු දෙන නෙමෙයි වැඩි. ඔයාගේ කන්ෆිඩන්ස් අවුට් යනවා. ඔයාගේ පේපර් එකේ ආතල් එකේ හරි හොඳට කන්ෆිඩන්ස් අරගෙන ලියලි හිටපු එක අවුට් යනවා. ගාන හදන්නේ ඕන. ඒක අවුට් ගිය ගමන් පේපර් එක අනිත් ගණන් ටිකට බලපාන. ප්‍රොෆෙසර් නිකන් ලකුණු පහක් දුන්නා වගේ නෙමෙයි. පහක් කියන්නේ එක ලකුණක්වත් නැහැ. එයා නිකන් නේ අර ලකුණු 10න් 5ක් දුන්නා වගේ නෙමෙයි උකට. 10න් 5ක් 10ක් දුන්නා වගේ නෙමෙයි කන්ෆිඩන්ස් අවුට් ගිය ගමන් පේපර් එකම අවුට් යනවා. ඒක නිසා ෆැඩේස් කොන්ස්ටන්ට් එකක් බයි හට් තියාගන්න 96,500. මේ ට්‍රූ වැලියු ලියුවා. හරි. ෂේප්. හරි. ඊට පස්සේ ටක් ගාලාම අපි මේ කැල්කියුලේෂන්ස් වල ඕන කරන කාරණා මතක් කරගමු. පොඩි දේවල් ටිකක්. හරි. calculations වලට ඕන කරන කාරණා right so for calculations මේක පට්ට ලීසි කතාවක් අවශ්‍ය බරෝබර් මේ calculation එක ලොකුවට නෑ මේකේම calculation ලොකුවට නෑ හරිද ඒක මුලින්ම මහන්සි කරන calculations නෑ calculation types දෙකයි තියෙන්නේ එකක් තමයි ECL වලින් calculation එක අනිත් එක current එකේ use කළ time එකේම වෙන calculation එක QK size ID use කරන calculation එක calculation type දෙකයි තියෙන්නේ හරි දෙකයි තියෙන්නේ මේ equations තුන දැනගන්න ඕනේ හරි right the equations are written here alright just go to the stuff quickly to calculate cell potential මොකද්ද මේ cell potential කියන්නේ right calculation කරන කතාවද ළමයි හරි පුංචි දේවල් ටික දැනගන්න ඕනේ අපි ඒ ජාති calculation එක කරමු අපි මේකේ අන්තිම කැලේදී right ඔයාලා දැනගන්න ඕනේ short note එක දැනගන්න ඕනේ equation තුනයි තියෙන්නේ පළවෙනි තමයි මේක right E cell equation, cell potential. This is also referred to as the EMF of the cell. What is EMF? Electromotive force. Equation to come up with the electromotive force of the cell potential. Mukaddu, what is this? Electromotive force of the cell potential means that is the potential difference between the two terminals of your cell. तन्नुको half cells दिया set कर ला cell या convert करा गया EMF is the voltage difference between these two terminals of the cell. इधर भी voltage difference तमा EMF के लिए electromotive force के लिए ना cell potential के लिए और वो सामान्य बैटरी गත්තම කඩින් බැටරි එකක් ගත්තම ඉතින් අර ගහලා තියෙන 1.5 volts කියලා 1.5 volts කියලා ඒ මොකක්ද ඔයා වෝල්ට් මීටර් එකක් අරගෙන කඩින් අලුතින් ගත්ත බැටරියට අරගෙන වෝල්ට් මීටර් එකක් අරගෙන අර ටර්මිනල්ස් දෙක ගැහුවා නම් ටර්මිනල්ස් දෙක සෙට් කරා නම් that will be the voltmeter reading. මෙතන මම සෙට් කරා නම් at 1.5 will be the voltmeter reading. ඒ මොකද්ද? That is the potential difference between the two terminals of the cell. හරි? හරි. ඕකට තමයි cell potential කියලා කියන්නේ. Or the electromotive force of the cell කියලා. That can be calculated by just connecting a voltmeter to the two terminals of the cell. Right? The voltmeter reading is the E cell. Right? E cell or EMF of cell. It is denoted with this symbol E cell. E cell के symbol එක තමයි. හරි? The potential difference between the two terminals of the cell. Right? So that can be calculated by, you have a specific equation to calculate that thing. That can be calculated by the E cell, the potential difference or the EMF of the cell can be calculated by considering the reduction potential value. Let's say, right, this one is the cathode. I took the other here. This is anode. Say this guy is with some reduction. These are the reduction potentials of anode and cathode. For each of the electrodes, they will carry some characteristic reduction potential, right? හැම electrode දෙකටම reduction potential එකක් තියෙනවා. Reducing ability එකක් තියෙනවා. Some numerical value is there for that, right? If you know the numerical value of those reduction potentials of those two electrodes, you can come up with the cell potential or the electromotive force. That will be the difference of those two. So that will be given by E naught cathode minus E naught anode. This is the most important reaction in these calculations. E cell is equal to E naught cathode minus E naught anode. This is the difference between the voltages of the two terminals. Anode එකේ voltage එකයි cathode එකේ voltage එකට difference එක තමයි cell potential කියන්නේ. Remember, this one is a larger value and this one is a smaller value. See? So that you are reducing some smaller value from a larger value, right? So that there should be a positive value. Right? So this thing tallies with what you have written here. Alright? Alright? Okay. දැන් කවුරු හරි අහන්න පුළුවන් ඇයි ඉතින් cathode minus anode මොකක්ද කියලා. ඒ anode minus cathode ගන්න බැරිද කියලා. හරිද? ඒ ඔය cathode minus anode ගත්තා. ඒක රීසන් නැත්නම් ඔය කියපු එකම තමයි. මේක ස්පොන්ටේනියස් එකක් නිසා අර ඉක්වේෂන් ටැලි වෙන්න E cell එක පොසිටිව් වෙන්න ඕන. As this one is spontaneous, this chemical cell things is spontaneous. To agree with the delta G naught that equation, the E naught cell should be positive. For E naught cell to become positive, you have to deduct a smaller value from a larger value. Now positive වෙන්නේ එහෙම වෙන්න නම් you have to take the cathode minus anode. ඔය කියන හැම එකම ගානට රිලේට් වෙලා තියෙනවා. හරි? අර ගානට අර නේද සෙට් කරන් යනකොට එහෙකට එකක් කන්ෆ්ලික්ට් නැති වෙන්න ඕනේ. රවුම ගියට පස්සේ ඔක්කොම ටික ගානට සෙට් වෙලා තියෙනවා. Conflicts. So that we have to take the cathode minus anode. So E naught cell is always E naught cathode minus E naught anode. Right? You can't change that equation. Right? Or sometimes it is referred to as E naught cell is equal to E naught RHS minus E naught LHS. We'll discuss that in later. Right? LHS, RHS. This is according to the cell diagram, which we are going to learn next. Cell diagram. So such an equation is also there. So normally in cell diagram, right, at the right hand side cathode is written, at the left hand side anode is written. Right? So such an equation is also there. So that is the first kind of equation we should know to do some calculations regarding the electrochemistry. Right? Then, right, we should know some more equations, some little equations as well. So the second thing we are going to discuss here is charge and moles. Charge and electron moles. So we know with this kind of setups, right, the electrons are moving from anode to cathode. Electron flow is there, so charge flow is there. So we have an equation which relates the charge to the number of electrons or moles of electrons went through the external circuit. Right? And the equation is Q is equal to NF. Right? So this is a charge went through the external circuit in coulombs. This is the number of or moles of electrons passing through the external circuit. This is Faraday's constant. Which is, let's say, 16,500 coulombs mole. Normally in calculations we use that value, right? So this is comes in terms of moles and coulombs mole. The mole thing will cancel off and the charge coming in coulombs. Alright? Make a unit take moles. Make it take a coulombs mole. Or you multiply karaddi mole kala kapila gila coulombs වලින් charge එකනවා. Right? So you can use this equation. Actually to come up with the number of moles of electrons. So electron moles passing through the external circuit can be calculated with the use of this equation. So if you are to subject the n, it will give you QOF, that means charge over 96,500 coulombs mole. So you have to represent charge in coulombs so that CC will cancel off to give you the electron moles, right? So this is really important. Nah? In calculations, the electron moles passing through the external circuit can be calculated by dividing the charge by 97,500, right? That will be used. Huh? Okay, use no idea. මෙන්න මේ charge එක හොයන්න පුළුවන් විදිහ මොකද්ද? This charge here can be calculated with the use of which equation? The equation number 3. The Q is equal to actually IT, which is also known from a more small ages. The charge is given by what? Current into time. Current into time, right? So charge This is the relationship between the charge, current and time. So let's say if you had done the process for 10 seconds of time with the use of 2 milliampere current. Let's say you have done the process with use of so let's say you have obtained 2 milliampere current time. Sorry, if you had obtained 2 milliampere current by this cell, right? By this cell, let's say you have obtained 2 milliampere current for 10 seconds of time. Then you can calculate the Q, the charge involved there, with the use of IT. With that, you can come up with the number of moles of electron exchange through the external circuit. We'll do such kind of calculations, right? अब major calculations करूँ. For that, this is the third equation, which is useful, right? Because IT. हरने, UT को उन्हें ना. හරි. අපි මේ සෝල් බ්‍රිජ් එක ගැන කතා කරලා ඉවරලා බ්‍රේක් එකක් ගමු, right? તો සෝල් බ්‍රිජ් එක කතා කරමු. මොකද ඒකට අපිට කෙලින්ම බ්‍රේකින් පස්සේ අර අපිට එක්සැම්පල් ක්වෙස්චන් එක කරලා ක්වෙස්චන්ස් වලට යන්න පුළුවන්. right? එතකොට මේ ෆන්ඩමෙන්ටල්ස් එක මුලින් කතා කරලා ඉවර කරමු අද. මේ වෙලාවේ ෆස්ට් සෙෂන් එක ඊට පස්සේ අපි ක්වෙස්චන්ස් වලට යමු. අරලා මේක ලියා ගන්න මෙන්න මේ කැලේ ලියා ගන්න පොඩ්ඩක්. අර අතන ඔයගොල්ලෝ රූල් දෙකක් ඉඳ තියෙන්නේ. So electron moles are equal to charge divided by 9,500 coulombs mole. Try this thing. At the space provided there. Two rules are there. අපිට අග්ගාලා මේ සෝල් බ්‍රිජ් එකේ users functions ගැන පොඩ්ඩක් කතා කරමුද? Right? Okay, quickly discuss about the functions of Soul Bridge. Let's come to this picture where we had started our discussion. See, what is the Soul Bridge? Yes, Soul Bridge is actually kind of connecting method. Soul Bridge is connecting method. Alright, Soul Bridge Soul Bridge is kind of a connecting method, right? Of two half cells. Half cells connect करने method है Soul Bridge की क्या? तो half cells से connect करने method बहुत थी ना. Most commonly used method is Soul Bridge. So you can go through a membranes as well. अकाल नुक कथा करे metal electrodes use कर membranes use काम बोलूँ. Right? ये वाली methods थी ना. The most commonly used stuff is the Soul Bridge. So that some questions may be asked. Right? With the Soul Bridge. Okay. The first thing. What are the uses of the Soul Bridge? Soul Bridge is the uses now. The aim is Soul Bridge use करा. Alright. There are two uses there. The first thing is very clear. It is used to connect the two half cells. Right? And we remember the half cells are connected. Alright. Connect the two half cells and completing the circuit is done by the Soul Bridge. Alright. Put over here. Just write. After that I'll explain how the circuit is completed by that. First use of the Soul Bridge is functions. Connecting the two half cells and completing the circuit. Connecting the two half cells and completing the circuit. That is one thing done by the Soul Bridge. half දෙක connect කළ completing circuit. මොකද්ද completing circuit කියලා කියන්නේ ළමයි පොඩ බලන්න. Connecting two half cells කියන එක නම් understood. What is meant by the completing circuit බලන්න. දැන් මෙහෙමනේ. දැන් හිතන්න ඔයා anode එකකට පස්සේ the electrons are released from here. Electrons are coming towards the cathode. එතකොට external circuit එකේ charge flow එක දිනනවා. හරි. එතකොට මෙතනින් charge flow එක වෙන්නේ කොහොමද? දැන් circuit එක complete වෙනවා මේ charge flow එක ගන්න දිනනවා. හරි. From here to here how the charge flow occurs? කොහොමද මෙතන charge flow එක වෙන්නේ? That is through the soul bridge. How come? කොහොමද වෙන්නේ? මේක වෙන්නේ ළමයි. දැන් ළමයි මේක oxidation එක වෙද්දී දැන් හිතන්නකො oxidation එක වෙද්දී හිතන්නකො මෙතන metal එකක් හිටියේ කියලා. metal එකක් හිටියේ. Let's say you have something zinc. Oxidation එක වෙද්දී මොකද? Let's say you have some zinc sulfate solution with some zinc. When the oxidation occurs, what happens? Zinc will dissolve and come up as zinc 2 plus aqueous. Oxidation මොකද වෙන්නේ? Zinc solid එක oxidize වෙනවා zinc 2 plus වලට. Oxidation at the anode. Then earlier before the process you had same amount of cations and anions in the solution, but as zinc guys dissolves to be with zinc 2 plus aqueous, now you have more cations in the solution. You become more positive here. Let's say this is a kind of a copper sulfate solution and kind of copper rod dipped in there. So when reduction occurs here, what will happen? Reduction means copper 2 plus things will deposit by absorbing 2 electrons as copper. When copper 2 plus things deposit here like this, what will happen? Earlier before the start of the process you had same amount of cations and anions in the solution. As cations are get deposited at the rod, now you have less cations here and more anions here, so the solution is negatively charged. Less cations because cations have been deposited here, now you have more anions here, so some charge will be developed at those solutions. So that what soul bridge do is it will release some ions, some opposite charge ions to these solutions. Soul bridge means it will contain some salt there. Soul bridge can salt the එක. It will release some positive ions. Let's say KCl is there in the soul bridge. It will release some positive ions towards this compartment as it is building some negative nature, and the negative ions of the soul bridge will be released to the positive solution to neutralize these solutions, so that you will clearly see some charge movements will happen through the soul bridge, so that circuit will be completed. How come? Let's concern the negative charge movement. Electrons are moving like this, and through the soul bridge negative particles are going towards anode. So negative charge movement is completed like that. Completing circuit. හරිද? මේක තිබ්බේ නැත්නම් මෙතනට circuit එක complete වෙන්නේ නැහැ. Charge flow එක වෙන්නේ නැහැ. That is what it says. Connecting the two half cells and completing circuit. This is first usage. දෙවෙනි එක maintaining the charge neutrality of electrolytic solutions. බලන්න මෙහෙම කරනකොට මොකද වෙන්නේ? When the negative charges are given to this will become neutral again. When the positive charges are given to this will become neutral again. So the second usage of the soul bridge is maintaining the charge neutrality of electrolytic solutions. Alright, just write the second usage. The end. Number 2, maintaining the charge neutral nature of electrolytic solutions. maintaining charge neutral nature of electrolytic solutions. Right now? Hard. अंतिम कारण है इंटेलेक्चुअल का तरह अंतिम कारण है requirements to fulfill when choosing a salt to salt bridge. Requirements. We have 3 requirements, right? When choosing a compound as the salt bridge chemical. Salt bridge chemical like use करा दी, compound select करा दी, अब इतना उन कारण तो नाती है ना. 3 requirements should be fulfilled, right? Let's come with one by one. Number one, just write. Number 1. After that, I'll explain, right? Number 1, right? Should be a strong electrolyte. Within brackets, ionic compound. Right? Ionic compound के नॉन ions තියෙන්න ඕනේ. නැතුව හිතනවා salt bridge use කරා වෙන මොකක් හරි. ඔය use කරා නිකන් CH3COOH which is weak acid won't ionize completely. That means when considering CH3COH, not all the CH3COH particles are as ions. Some appear as uncharged species, not ionized completely. So what then? तो कोटा लामाई आउट अपने इधर ये salt bridge के दिए chemical लगे मतलब negative हुआ इन्नो positive हुआ इन्नो देख इतना ना uncharged species जो मोदेन uncharged के किन्नो එතකොට මොකද වෙන්නේ? It will be a resistance for the movements of these charged particles. බාධාවක් නේද? දැන් මේගොල්ලෝ අන්චාර්ජ් වුණාට පස්සේ කෝකි පැත්තට යන්නේ නැහැ නේ, මෙහෙට යන්නෙත් නැහැ, මෙහෙට යන්නෙත් නැහැ. ඇට්‍රැක්ට් වෙන්නේ නැහැ. එතන පොසිටිව් එකක් ඩිවෙලොප් වුණාට අන්චාර්ජ් කට්ටිය පොසිටිව් එකට ඇට්‍රැක්ට් වෙන්නේ නැහැ. නිරුවයට ඇට්‍රැක්ට් වෙන්නෙත් නැහැ. මොකද වෙන්නේ? ඒගොල්ලෝ එතනම ඉන්නෝ. මොකද වෙන්නේ? ඒක නිසා ඔයාට මේ charge particles වලට move වෙන්න බැරි වෙනවා. ඉතින් එයාට effectively යාගේ කාර්යභාරය කරගන්න බැරි වෙනවා. So then this thing is unable to do its purpose effectively. Right now? Do its work effectively, right? So that is the problem. ඉතින් ඔක්කොම ions charge එකේ ඉන්න ඕනේ. positive negative වයි ඉන්න ඕනේ. positive charge species ඉන්න ඕනේ. ඒක ප්‍රශ්නයක් නැහැ. opposite terminal attract වෙනවා. Right? Alright. Second thing, number 2, right? Ionic mobility of 2 ions should be closely similar. Ionic mobility of 2 ions should be closely similar. Right? ඒ කියන්නේ මෙහෙමයි. ඒ කියන්නේ දැන් හිතන්න ඔයාට අයන්ස් දෙකක් ඉන්නවා. හරිද? තීරණ භාෂාවෙන් කිව්වොත් පොසිටිව් අයන් එක මෙහෙම ගිහලා මෙතනට ජොයින් වෙන වෙලාවෙදිම නෙගටිව් අයන් එක මෙතනට වැටෙන්න ඕනේ. Both should have same ionic speeds, ionic mobilities. හරිද? When the positive ions joins with the solution, at the same time the negative ions should join with the solution as well. ඒ කියන්නේ මෙහෙම පොසිටිව් එක එහෙම යනකොට මෙහෙම දෙන්න එකම වේගෙන් ගිහලා වැටෙන්න ඕන කොහොම. ionic mobility should be the same. හරි හදිස්සියවත් පොසිටිව් එක කෙනා හයියෙන් යන නෙගටිව් එකට හිමින් ගියොත් මොකද වෙන්නේ? මෙහෙම පොසිටිව් එකෙන් ගිහිල්ලා වැදිලත් ඉවරයි නෙගටිව් එක තාම මෙතන. පොසිටිව් එකට වැටලත් ඉවරයි. Then what will happen? There will be a charge build up in the soul bridge. Then that will affect to the reading here. That will be affect to the voltmeter reading here. Right? The voltmeter reading should show only the voltage difference between these two terminals. මෙතන charge build up එකකට මොකද වෙන්නේ? මෙතනයි තුනේම voltage difference තමයි වෙන්නේ. net එක. දැන් මෙතන charge build up එක නැති වෙන මෙතන voltage difference එක නැති වෙන්න ඕන soul bridge ඇතුලේ. neutral වෙන්න ඕන. හරි. මූ හයියෙන් ගිහිල්ලා වැටිලා. මූ තාම මේ හරනම් මොකද වෙන්නේ? You will have a negative charge here. So කොට voltage එකට බලපාන. Then you are unable to come up with the potential difference of this. Right? So මෙයා වැටෙන වෙලාවටම මෙයාට එන්න ඕනේ. ionic mobility should be the same. So ඒ කියන්නේ සාමාන්‍යයෙන් දැන් KCL හොඳ වෙන්නේ ඒකයි. KCL ionic mobility will be dependent on the charge density. K plus Cl minus charge සමානයි. K plus and Cl minus are with same sizes as well. More or less similar. Sizes are closely similar. K plus and Cl minus both are with 18 electrons. Potassium 19, chlorine 17, 18 electrons. K plus and Cl minus. So ionic mobilities are almost same. So better for this whole bridge. So sodium sulfate එක දාන්න බෑ. බර වැඩි වෙන අවුල්. දැන් හිතන්න sodium sulfate බර මොකක් කරන එක. right නියම්. හරි magnesium sulfate හරියන්නේ නැහැ. magnesium 2+ පොඩි sulfate ලොකු එක්කෙනෙක්. හිමින් යන්නේ. magnesium sulfate දැම්මොත් මේ මූ වැටිලා ඉවරයි. මූ හිමින් යන්නේ. කොහොම? heavy particle sulfate. Magnesium sulfate is not good. Ionic mobilities differ. Right? So the KCl is better. With that purpose, NaOH හොඳයි. ඒ purpose එක. Na+ and OH minus. හැබැයි NaOH fail වෙන ඊළඟ purpose එක ළමයි. ionic mobility ගැන කතාරත් NaOH හොඳයි. But NaOH fails with the other purpose, right? Third one. Let's copy the third one. Number 3, the requirements to fulfill. The chemical of the soul bridge should not participate. The chemicals of the soul bridge should not participate in any kind of a reaction should not participate in any kind of reaction with electrolytic solutions at half cells. හරි. එන්නේ ඔය සරලව අපි කියන්නේ precipitation reactions, complex formations වගේ දෙයක් යන්න බෑ. උදාහරණයක් ගත්තොත් දැන් KCl කොච්චර හොඳ වුණත් you can't use KCl when you have when you have kind of Ag plus Pb2 plus cations in your anodic compartment. ඔයාගේ anodic compartment එකේ Ag plus ලා Pb2 plus වගේ ඉන්නවා නම් මොකද වෙන්නේ? KCl දාලා පුළුවන් දෙයක් කරන්න. When Cl minus approaches here, it will combine and precipitate the Ag plus ions. It will combine and precipitate the Pb2 plus ions if those are appearing at the anodic compartment. So that the concentration of Ag plus Pb2 plus will decrease because of the soul bridge. So that electrode potential will decrease. Electrode potential වෙනස් වෙනවා. E cell වල වෙනස් වෙනවා. ලොකු ප්‍රශ්න ටිකක් වෙනවා. We'll discuss those things at the next session. Right? එතකොට soul bridge එක කිසිම විදිහකට electrode reactions වලට බාධා කරන්න බෑ. electrode reaction බාධා කරන්න බෑ. electrode equilibrium බාධා කරන්න බෑ. When you have that electrode equilibrium, the Ag plus coming up with the electron to form the Ag solid, that equilibrium, that equilibrium will be disturbed if Cl minus comes and join the Ag plus. ඒක වෙන්න බෑ. ඒකට KCl හොඳ වුණාට KCl අපිට use කරන්න බෑ when Ag plus Pb2 plus kind of things they are at the anodic compartment. Right? හරි. නැත්නම් අනිත්‍යයට උලන්නේ. තව NOH use කරන්න බැරි වෙන්නේ ඒකයි. Because OH minuses will precipitate with most of the cations නේ. ඒක නිසා ඉතින් ඒව use කරන්න බෑ. Right? හරි ලියන්නකො example එක දාන්න. example දාන්න. Example. Right? Even though a third one example occur, even though KCl is considered as a good chemical for the salt bridge, KCl can't be used when Ag plus Aq or Pb2 plus Aq ions are there at the anodic compartment. Red color line as Cl minus ions will precipitate AgCl slash AgClO PbCl2. AgCl slash PbCl2 disturbing the anodic electrode equilibrium. By disturbing the anodic equilibrium. ඉතින් එහෙම මේ cell equilibrium වලට නැත්නම් මේ electrode equilibrium වලට disturb කරන්න බෑ. Precipitation එහෙම කරන්න බෑ. හරි. shape නේද? හරි. Okay, that is all about salt bridge. Right. අපි හිතනවා මෙතනින් break එකක් ගමු. ඊට පස්සේ ඊළඟ half එකේදී අපි question type එකක් කතා කරමු. කොහොමද questions එන්නේ කියලා. Right. ඒකට අපිට අද පුළුවන් වෙයි electrochemical cell එක ඉදිරියට කරගන්න. අපි night sessions වලදී electrolysis කතා කරමු. Right. හරි. Right. එහෙනම් අපි break එකක් ගමු. Let's start. So you have a warm-up question there. Right, let's quickly go through the things there. Right, the page number 3. It is said that they have constructed kind of a dining here. Right, dining cells there. Right. It's kind of a common question, right? General question, right? With the use of this, let's try to have an idea how the questions will be asked from this section. Right? Direction of the electron flow is marked. Right, you have the zinc solid and some zinc 2 plus solution. Basically, a standard cell is constructed with use of 2 standard electrodes. They have used 1 mole solution, right? So this is Daniel cell. Daniel cell is the electrochemical cell constructed with zinc electrodes and copper electrodes, right? Okay. So some reduction potential values are also given. For zinc 2 plus electrode, that is given as minus 0.76 volts, and for the copper rulers as well, they have given the reduction potential values. Now if some value is given as E0 value, remember those are reduction potentials, right? Not any other. Those are not just potentials, those are reduction potentials, right? These are referred to as, these things are referred to as standard reduction potentials. Reduction potentials. Right? Okay. Right. So first question they are asking is identify the cathode and the anode. So what is the cathode? What is the anode? Basic. Sorry. This is cell, no? Right. Cell is given as this cell. So if they have given some value regarding an electrode, that is referred to as the reduction potential, right? Electrode dak sambandha value sila diyana reduction potential is given. This is the cell potential, right? That is clear. This is cell potential. No worries with that. Right. Okay. So first question they are asking is identify the cathode and the anode. Yes. Tell me which electrode is your cathode, which electrode is your anode. So to identify the cathode and the anode, basically there are 2 ways of giving the data. Right? There are 2 ways of giving the data to identify the cathode and the anode. One way is actually giving you the electron flow direction, right, of the external circuit. If the electron flow direction of the external circuit is given, then what is the anode, what is the cathode? Anode is the terminal where the oxidation occurs, where electron removal happens, right? So electrons are removed from here, electrons are removing from here. So this is the anode. right? Then what is the cathode? Cathode is the terminal where the reduction occur. That means the terminal which accept the electrons. So you see here the electrons are accepted. Electrons are accepted. This is the cathode. That is the first method of identifying the anode and the cathode, right? So what is the first method? Right, cathode is a terminal where the oxidation occurs, right? Terminal where the oxidation occurs. So if you are to come up with a picture, right? Sorry, cathode, no? Cathode is the terminal where the reduction occurs, right? Sorry, where the reduction occurs. If you come up with a picture, electrons are coming towards cathode. Because anode is the terminal where the oxidation occurs. That means electron removal happens at the anode. So with the use of that, you can identify the anode and the cathode here, right? So for this one, your anode is zinc 2 plus electrode and cathode is copper 2 plus electrode. So cathode is copper 2 plus electrode, right? So your anode is zinc 2 plus electrode. Don't write it as just as zinc electrode, copper electrode, right? When representing an electrode, just indicate both the redox couple, right? So if you are referring it as zinc electrode, it could be zinc oxide electrode as well. It could be as a metal insoluble salt electrode as well. So just clearly mention the redox couple when you are naming an electrode. So anode is zinc 2 plus electrode, cathode is copper 2 plus electrode, right? That is the first method, one method you can use to identify the anode and cathode by just looking at the electron flow direction of the external circuit, right? Okay. If that is not given, what is the other method to identify the anode and the cathode? The second method of identifying the anode and the cathode is actually by concerning the electrode potentials. These values, electrode potentials, right? The cathode is the terminal where the reduction occurs, no? So that means cathode is a terminal with a higher reduction potential. With the terminal with higher reduction potential, reduction will occur. Then what is the anode? Anode is a terminal with a lower reduction potential. With the lower reduction potential, when the reduction potential is low, reduction won't occur. Oxidation will occur, right? So by looking at the by actually concerning the values of reduction potentials, by comparing the values of reduction potentials as well, you can come up with the anode and the cathode, right? For that what you use, right? So that is the first method. The second method is, right, electrode with electrode lower E naught. Lower reduction potential. So here is the electrode with higher reduction potential, right? Okay, but for this question, right, they have provided data by giving the electron flow direction, right? So we had to use that thing. So cathode and anode are identified. Next one, try the reaction at zinc stroom glass electrode when S is closed and opened, right? Reactions at zinc 2 glass electrode. Right? When S is closed, another thing is when S is open. So referring to closed system, closed circuit and a open circuit, right? Okay, let's write. So what is this zinc 2 plus? This guy is your anode. This guy is your anode. That means oxidation would occur. Oxidation should occur when closed circuit situation is there, right? So let's write oxidation. So to the side of oxidation we have to place these two guys. So it should be the side, it should be like starting from a low oxygen state going towards a high oxygen state, the oxidation. So you should start from zinc solid and Cn2 plus should be at the product side, right? As we are referring to the anode, it should be oxidation. So 2 electrons should be written. This is straight arrow reaction. What is the oxidation there? As S is closed circuit. Next one, open circuit. For any electrode, if you are dealing with the open circuit situation, then you have to come up with a double arrow, the equilibrium reaction. Open circuit means equilibrium reaction. When coming up with equilibrium reactions, always you have to place the two components in a way the forward reaction gives you the reduction. Alright? Then we are open circuit ගත්තට පස්සේ equilibrium reaction එකක් ලියන්න ඕනේ. එතකොට ඔය arrange කරන්න ඕනේ Ross couple එක. Forward reaction එක, reduction එක විදිහට. Even for the anode. Right? So forward reaction has a reduction reaction. So zinc 2 plus should be at the reactant side and zinc at the product side. Forward reaction, reduction. So 2 electrons should be read. Right? Okay. Next one. Number 3. Try the reaction at copper 2 plus electrode when S is closed and open. Okay. Let's write. Reaction set copper 2 plus electrode. When S is closed and then when S is open circuit and closed circuit situation, right? So first of all identify whether oxidation or reduction occur, right, when the circuit is closed. So copper 2 plus is your cathode here, or one can say as the copper 2 plus electrode, electrons are coming towards that. That means reduction, right? That is reduction. So you have to write or you have to place the redox couple in a way that it represents the reduction of oxygen states. So at the reactant side you should have great oxygen state, and at the product side you should have low oxygen state to represent kind of a reduction. So you have to start with copper 2 plus. Forming copper. If the circuit is opened, that means you are supposed to come up with the equilibrium reaction, open system. So when we are writing equilibrium reactions, it is always needed to come up with the forward reaction as the reduction reaction. So it is also same like earlier, but with a double arrow instead of the single arrow. Right, no? Okay. Next one. Cell reaction. Cell reaction. So how to come up with the cell reaction? Right? Just come up with the overall redox reaction, right? That is the cell reaction. Cell reaction is the overall redox reaction, right? Okay. So if you know the reduction half and the oxidation half, how to construct the overall redox reaction? Just combine them, right, such that you will cancel off the electrons at the both side. Just combine them, right? So with both the reactions, oxidation as well as reduction, you have 2 electrons each. Yes. So combine the two. The cell reaction. Right? Just create the two. This one and this one. In a manner where the electrons will get removed ultimately when adding the two. So you can just simply add the two. The 2 electrons on the left hand side there will be cancelled off by the 2 electrons which will come to the right hand side when adding the second one with the first one. Right? So it is going to be 1 plus 2 will give you zinc solid plus copper 2 plus, those guys are at the left hand side, and at the right you have the zinc 2 plus aqueous and the copper solid. Right. When the SC is opened, when the switch is opened, right, don't worry Lamai. When coming up with the cell reaction, if you are dealing with the open circuit situation, nothing to do much, right? Just write the same cell reaction as in closed system, but with a double arrow here. හරිද? cell reaction ලියද්දී අර වගේ විනාශ වෙන කතාවක් නැහැ. cell reaction open system ලියද්දී closed system එකේ ලියපු එකම ලියන්න, but with a double arrow giving you equilibrium, representing you equilibrium, right? Right, no? Okay. Number 5. Cell notation. Cell notation. cell notation. Okay, so cell notation is also referred to as the IUPAC nomenclature of the cell, or sometimes the cell diagram. All the words are used for the same thing, right? Cell notation, IUPAC nomenclature of the cell, or cell diagram even, right? How to come up with a cell diagram for any given cell, or how to come up with the cell notation or IUPAC nomenclature of any given cell. So when it comes to cell notation, what you are actually doing is you are supposed to write all the components in your picture. You are supposed to come up with all the components actually in order in your picture, starting from the anodic metal to cathodic metal, right? That is how a cell diagram or IUPAC nomenclature is written for a cell. You are supposed to write all the components in order. So to write all the components in order, starting from anodic metal to the cathodic metal, right, of the picture given, right? පින්තූර දින anodic metal එකේ ඉඳන් cathodic metal එක වෙනකන් තියෙන ඔක්කොම components ටික order එකට ලියන්න ඕනේ. That is what we are referring to as cell diagram or the cell notation or the IUPAC nomenclature, right? Have to start with the anodic metal and have to end at the cathodic metal. All the components should be written in order, right? Okay, let's write. Here the anodic metal, that is zinc there, zinc solid. Have to come up with the physical state as well. After that, you have the zinc 2 plus aqueous solution, and between zinc solid and the zinc 2 plus aqueous solution you have phase boundary. So two different phases. Composition differs. If the composition differs, then we refer them as two different phases. This is solid and this is aqueous solution. So concentrations changes. So that phase change will be denoted by a single line like this, vertical line. After zinc solid, phase change occur and come up with zinc 2 plus aqueous. You have to maintain and you have to write the strength as well if it is provided. As we are referring to a standard Daniell cell, it is a must to come up with the concentration. Standard electrodes are used. Right? So you have to write the things in order. Right. Start with zinc solid, anodic metal, then come to the zinc 2 plus aqueous, then you come to the salt bridge. Then you come to this phase, the salt bridge salt. Another phase change occur. Normally salt bridge chemical is with the agar gel. Salt bridge chemical සාමාන්‍ය තියෙන ළමයි agar gel එක සාමාන්‍ය KCl ගත්තොත් KCl not in aqueous but agar. So you definitely see a phase change there. This is aqueous solution. This is kind of a gelatinous stuff. උළුවේ ගාන gel තියෙන නියම තමයි. Right? So phase change would occur going from here to here. Right? So that you have to mark kind of a vertical line. Then again, when coming from agar gel to aqueous solution, another phase change occur. aqueous solution එකෙන් agar gel එකට ඇද්දි phase change එකක් වෙනවා. ආයෙත් agar gel එකෙන් aqueous solution එකට ඇද්දි ආයෙත් phase change එකක් වෙනවා. Right? And when coming from agar gel to the copper 2 plus aqueous, another phase change occurs, so that another vertical line should be written before the copper 2 plus aqueous. Right? and you have the copper 2 plus aqueous thing. So normally when representing a salt bridge, you would see this kind of double vertical lines would appear. If you are with a salt bridge, right, with your cell, this kind of a double line situation will appear. This is actually representing salt bridge, right? Which is the connecting method in this case. Right? And after the copper 2 plus aqueous, we will come to the anodic metal, so cathodic metal, that is copper solid. Right now? Okay. So with the phase change, you will come up with the copper solid. So this is the cell notation. Right? You have to start with the anodic metal, which connects to the external circuit, and you will end up with cathodic metal, which connects to the external circuit, and in between you have to place all the components of the cell in order. Right? That is how you are supposed to copy the cell notation of the IPAC nomenclature of the cell, sometimes referred to as cell diagram as well. Right? Okay, that is your cell notation for this linear cell. Now, few other connecting methods are also available. Salt bridge is just one connecting method. Right? Salt bridge is just one connecting method. Right? So I'll write like this. Connecting method represent connecting method. The method we use to connect the two half cells, right? So if a salt bridge is available as the connecting method, normally you would see two line situation. This is a salt bridge. Sometimes there would be a membrane, semi-permeable membrane stuff. So those are normally referred to as, those are normally indicated with this kind of dotted lines, right? When membranes are appearing. So those are the commonly used two connecting methods. In this case, kind of salt bridge is used. Right? It is cell notation. Keep that in mind, right? When writing cell notation, you have to start with the anodic metal, and you have to write all the components in order until you meet the cathodic metal, which connects to the external circuit. Right now? Okay. Next one. Number 6. See. Calculate the E naught copper 2 plus. Right? We are supposed to calculate the E naught copper 2 plus. Right? E naught of kind of a electrode. Right? As the reduction potential of zinc as well as the E cell is given. So now we can come up with the reduction potential of copper electrode as well, by using the E cell is equal to E naught cathode minus E naught anode. That's the equation. Let's come up with that. Number 6, right? E naught cell is equal to E naught cathode minus E naught anode. Right? So what is your cathode? Your cathode is copper electrode. Your anode is zinc electrode. And E cell value is also given. So E cell value here is plus 1.10, that is given, na? And anode value is also given. Zinc is your anode, that is given as minus 0.76. And what you need to find is the electropotential of cathode, which is your copper 2 plus. Right now? So, let's subdivide this up. That will give you, this becomes positive and becomes minus when it comes to this side, give you some plus 0.34. Right now? Okay. Right. Things are clear? Right. Next question. Comment what changes happen to following when copper 2 plus concentration increase to 2 molar decimeter cubes. Right, for a 2 molar solution. See, number 7. Right, when copper 2 plus increase to 2 mole, because with the standard cells, with standard electrodes, the concentrations will appear as 1 molar, right? So now you had increased to 2 molar. So what will happen? The first thing is, what they are asking is what will happen to the electrode potential of copper 2 plus. Right? What they are asking is whether it is increasing or decreasing. How to comment? How to comment? So if they are asking about the electrode potential, if they are asking about the electrode potential, what happens to the electrode potential? First you need to come up with the electrode equilibrium. Consider electrode equilibrium, that is the way of answering the question. If they are asking for what will happen for electrode equilibrium, for electrode EZL value, sorry, what will happen for electrode potential, you need to come up with the electrode equilibrium. If they are asking you what will happen to the cell potential, then you need to come up with the cell equilibrium. As this all about electrode equilibrium, you need to come up with the, so as this is all about electrode, you need to come up with the electrode equilibrium. So what is the electrode equilibrium? It's copper 2 plus. Basically when writing the electrode equilibrium, always you are supposed to come up with the forward reaction as the reduction reaction, right? What is the point we are supposed to apply here? The point is any factor which will favor the forward reaction of the electrode equilibrium, right, will increase the electrode potential. That is the point. Any factor which will favor the forward reaction of the electrode equilibrium will increase the electrode potential, right? Just write that thing anyway. ලියා ගන්න පොඩ්ඩක්. හරි පොඩ්ඩක් මම මෙතන ලියන්න කවන්නේ මොන පොඩි ලියන්න. right? point තමයි any factor forward reaction will increase electrode reaction නේ. Any factor which favor forward equilibrium electrode reaction will increase the electrode reduction potential. Right? ඉතින් reverse reaction එක favor කරනවා නම් decrease වෙන එච්චර තමයි කියන්න ඕනේ. හරි. ඒ point එක. તો මේක මොකද වෙන්නේ? See? Here, as we increase in the copper double concentration, forward reaction will be more favored. As the general principle tries to decrease the amount of copper double by doing more and more the copper double consuming reaction, which is the forward reaction. So we can write as forward equilibrium, as forward electrode reaction favors reduction potential increases. So we can write copper double loss reduction potential increases. Right? අර electrode potential එක ගන්න ගහන්නේ electrode equilibrium එක consider කරනවා. Cell potential එක ගන්න ගහන්නේ cell equilibrium එක consider කරනවා. Right, na? Let's copy 2. Number 2 is about cell potential. So, what is the point there? Any factor which favors forward equilibrium cell reaction will increase E cell. Right? So let's apply that point there. So this equilibrium cell reaction as you are increasing the copper double concentration, forward reaction will be favored, so the E cell will definitely increase. As forward cell reaction favors cell potential, E naught cell increases. The reverse එක වේ වුණොත් decrease වෙනවා. හරි. So increases. Harane? Antima case. It's clear, no? Let's come up with the 8th case. Final question. Right? See what they are asking. If 2 ampere current was produced for 1930 seconds using this cell, calculate the mass of copper deposited at the cathode. Right? They are saying this thing is done for 1930 seconds. And they are saying they have produced 2 ampere current from this cell. They have produced 2 ampere current from this cell. And calculate the mass of copper deposited. Mass of copper deposited, that is what they are asking. So, how to solve this one? Mass of copper deposited. Just think of the goal you need to achieve. Mass of copper deposited means that is all about the electrode reaction involving copper. What you have to concern is all about the electrode reaction involving copper. That is what happens normally. The two reactions are to be occurred. What is the reaction here? Zinc solid converting zinc 2 plus 2 in a, that means zinc solid converting zinc 2 plus aqueous. That means your mass, the solid mass will dissolve and come to the solution. That is one observation we see when you carry out this process continuously. The mass of the anode will dissolve. On the other side, as copper electrode participating in kind of a reduction, this kind of process, the copper 2 plus ions at the solution will get deposited at the cathode. So mass of the cathode will increase. Those are two observations though. And what they are asking is the amount of copper deposited there at the cathode. So what we need to consider is this cathodic reaction. What they are asking is the mass of this thing. So you can find out the mass of this thing if you know the moles of the copper deposited. You can come up with the moles of the copper deposited if you know the electron moles involved with the process. If you know the electron moles involved with the process, half of the moles of copper will produce. So if you know the moles of copper, you can come up with the mass of copper. That is our ultimate goal. Right? So our first thing is to come up with the moles of electrons involved with the process. Right? For that, we can use the Q equals NF and the Q equals IT. IT things are given. Right? That is the approach. So let's solve. Right? finding out the electron moles. Involved. For that, first of all, you have to complete charge. Q equals IT. I means 2 amperes. 2 amperes, no? T in seconds. The sign should be used. The electron moles. How to find the electron moles? You have to charge in coulombs, right? You have to divide this charge in coulombs with 96,500 coulombs mole. That will give you the electron moles. Right now? What is this value? Zero 0.04. Then we can compute the mass of copper. For that, we need to complete the cathodic reaction where the copper is involved. Right? So this amount is 0.04. So we need to copy this amount. That is half of that, right? That is what deposited, right? That is half the amount of electron moles. Right? So that then we can copy the mass with the use of G mole minus 1 data for copper. Copper is 63.5. So number is going to be 127. 50 decimals, right? Or one can say 127 milligrams. That is how a simple calculation will be done. Right now. So that is all for the theory part, right, of the electrochemical cell, right. Let's try to do some one of the yellow questions appear in there. Right. So I'll give you 10 minutes, right? So just do the question number 1, appearing page number 40, which is the 2020 yellow question, right? So 20 yellow question number 1. Just try to complete that thing. Part 1 and part 2 both you can do. Just try to do the question. Eh, 63.5 होती है डेसिमल स्टूडेंट क्या है बोलो या ना like මේක ළමයි වැලියු එක 1.27 grams න ළමයි අර මේ E not O2 gas OH minus එකස් එකේ වැලියු එක වැදිලා නැහැනේ. ඒක that is plus 0.40. Right? The value is not written there properly. E naught let's write that thing, right? Okay, let's start to do this one. Alright. Follow. See the first one. To complete the properties of electrolytic cell and galvanic cell, copy and complete the following table. Right? Alright. So first thing is about oxidation, half reaction. Right. Sorry. Electrolytic cell, galvanic cell. Galvanic cell means electrochemical cell, right? Okay. Oxidation, half reaction. So oxidation always happens at the anode. No worries. This is definition. The terminal where the oxidation occurs is the anode. The terminal where the reduction occurs is the cathode. This is definition, right? For electrolytic cell, it can say anything. Reduction. Reduction at the cathode. It is definition, right? Cathode means the terminal where the reduction occurs. Anode means the terminal where the oxidation occurs. That is valid for all the processes, right? C. Sign of E cell. D. Electron flow. Is spontaneity. Okay. Right. So let's come up with the first spontaneity first of all. Galvanic cells are spontaneous. Redox reactions of the galvanic cells are spontaneous. But for the electrolytic cells, the opposite. We need to apply some energy to do the process. That is opposite, right? So without a energy input, you won't see the silver plating on the stuff, right? Electroplating can't be done without energy supplement, so non-spontaneous. We'll learn with the next lesson about the electrolysis, right? So spontaneous means delta G is negative. Is positive. Right. Electron flow. Electron flow is actually always from the electrode which releases the electrons to the electrode which accepts the electrons. Electron flow electrons release electron accept electrode. What is the terminal which releases the electrons? Anode. Which accepts the electrons is the cathode. So electron flow is always from anode to cathode for any process. Anode to cathode. Simple logic, always electrons releases from anode and accepted from the cathode. That can't be changed. Right, sign of E cell. So as we know, delta G is equal to minus NF E naught cell. As these two guys are positive, definitely, right, to have the same sign here, let's say. So basically the signs of these two guys should be opposite. Sorry, the signs of these two guys should be opposite. That is what I need to say. If this is negative, then negative this becomes positive. If this is positive, this becomes negative. That's the idea. Signs of these two guys should be also opposite, as you have some negative value here, right? So as galvanic cell coming up with a spontaneous reaction, as the delta G is negative, then E naught cell is positive. As this is non spontaneous, delta G is positive, E naught cell should be the opposite, negative. Right now, that is how you are supposed to complete the table there. Actually, these are things which are changing. Other than that, other things are same. Right? Okay. Right, let's come up with the Roman number 2. This was the Roman number 1. Let's come up with Roman 2. Right. So I write from here. We may need some more space. Right, Roman 2. See, an electrochemical cell was constructed at 300 Kelvin by using some electrodes. These are given, right? Okay. So the picture looks like this. Zinc solid is there, some electrolyte and some platinum. Some porous cathode. Actually, nothing to worry about the picture, lamai. Don't worry about the picture. You can come to pictures. Don't worry about just apply the basics. Then you will copy the answers. Don't worry about the pictures they are going to give, right? These are not. Sorry. See what test they are saying, giving, right? A naught zinc oxide is given as minus 1.31. Given as plus 0. Right, okay. Some values, other values are also given, right? Okay. First thing, write the half ratios occurring at the anode and cathode. The first thing is actually no need of labeling this stuff. ඇත්තටම මේක ලේබල් කරලා තියෙන අවශ්‍යතාවක් නැහැ ඉතින්. ලේබල් කරන්න ඕනෙත් නැහැ ඇත්තටම. ලේබල් කරලා තිබ්බට. What is going to be the cathode and what is going to be the anode? So cathode is the terminal where the reduction occurs. That means cathode is the terminal with the higher reduction potential. This is high, this is low. Higher reduction potential means cathode. Lower reduction potential means reduction won't occur, oxidation occurs, that means anode. Right now? Write the half reactions occurring at the anode and cathode. First at anode, you have to label this stuff. Anode, see, anode we are supposed to come up with the oxidation, right? So we have to arrange the two guys in a way where you increase the oxygen state when going from reactant products. So zinc is with 0 oxygen state, this guy is with +2. So it should be from zinc to zinc oxide. So I'll write. Now we have to balance. So first balancing the redox atoms, that is done. Balancing the oxygen states, this is 0 +2, so some -2 is needed, 2 electrons. Then charge balancing with the use of medium. Medium is provided, basic medium. So some 2 of OH minus at this side. It is essential to write the physical state. Physical state annually and finally the hydrogen balancing. 2 hydrogens are there, so 1 H2 is needed here. Nothing to worry lamai hari. ඔය සාමාන්‍යයෙන් half ration balancing technique කරන්නේ. So at cathode, we are supposed to come up with a reduction reaction. So you have to arrange the two species where you start with the low oxygen state and you start with the high oxygen state and going towards the low oxygen state. Reduction, oxygen. So starting from here to here, we need to reduction. So O2 is converted into OH minus aqueous. Now the balancing. First need to balance the redox atom. ඒක අමතක කරන්න එපා මොකද? ඔක්සිජන් දෙන්නයි. අමතක කරුවොත් මරගෙලිය මුත් කරන් බැරිනවා. So this 0 oxygen state, balancing oxygen state, second step. This -4, -2 into 2. So you need to come with some +4 here, -4 here. For that 4 electrons are needed. Then balancing charges, -4 here, -2 here. Using the medium is OH minus. So another 2 of OH minus are needed for this side. Right? So these 2 and these 2 all together 4OH minus. What? Maybe they can't really 4OH minus. Finally, balancing hydrogens. You have 4 hydrogens, that means 2 H2s are needed. Right, next one. Overall reaction. So you are supposed to add the two. You are supposed to add the two, right? So let's consider this one as 1, this as 2. So you have to add the cathodic and anodic oxidation and the reduction reactions in a way that you will cancel off the electrons. So you have 2 electrons at the right here, you have 4 electrons at the left here. So you need to multiply this thing with 2 to cancel off the electrons. So 1 it's like 1 multiplied by 2 and add into 2. So that 4 electrons will come to here and cancel off when you are adding the stuff. So multiplied by 2 means 4 of OH minus. That 4 of OH minus will cancel off with this O. This becomes 2. First of all, I write all the stuff at the left hand side. Left side it was right again. Was the left side. 2H2O no. Because they came 2H2O se kapeno. They video. This thing. Then the other side, it will become 2 of zinc oxide. Other things cancelled off. Right now. Next one. Calculate the cell potential, in of cell. Simple, huh? In of cell. In of cell is equal to cathode minus anode. Right? So the cathode is this value, the higher value, where the reduction occurs. Anode with the lower value of the reduction pressure. This minus minus becomes positive. It's plus 1.71 volts. Right. No? Next one. So number 4. Set a direction of migration of OH minus ions between the electrodes. Right? So what should happen? Normally, in these cases, right, anions are travel towards anode, cations are traveling towards cathode. That is what happens even in the solar bridge. The anions of the solar bridge will travel towards the anodic compartment to neutralize the ions there. Cations of the solar bridge will travel towards the cathode, cations towards cathode, like that. So in this case, OH minus is kind of an anion, so should travel towards anode. Right? In such a manner, you can come up with the answer. OH minus are going towards anode, starting from the cathode. If you have to look at the equations here, still you can get the same idea. So at the anode, the OH minus are used as a reactant. So you should provide OH minus to the anode to do the reaction. At the cathode, the OH minus are released from the reaction. So OH minus are released from the cathode, accepted towards the anode to do the reaction. So OH minus are going towards the anode, releasing from the cathode. So migration of OH minus are from cathode to anode. Right? Right? From cathode to anode, or better to write it as, so from, what is the cathode? Just write from the electrodes. They are saying ions between the electrodes. It's better to write the correct electrodes there. From cathode means O2 OH minus electrode, anode number 5. When the cell operates for a period of 800 seconds, so the time is given as 800 seconds. At 300 Kelvin, okay, 2 moles of O2 are consumed. These are things they have provided. And what they are asking? Number of moles of electrons pass into the cell. First thing they are asking is number of moles of electrons pass into the cell. See? So now you need to relate the O2 gas and the electrons. See the equations we have written and see where you can find a relationship between the O2 gas and the electrons. That is what we are supposed to do, right? That is way of approaching the question. Right? So you can clearly see the O2 gas and the electrons appear with this, with the cathodic reaction. Right? From cathodic reaction, right? O2 gas to electrons are coming up with 1:4 ratio. So electron moles. So 2 moles representing one portion. 2 moles representing one portion. We need such 4 portions. Oxygen amount is 2 moles. We need such 4 portions as moles of electrons. So 2 moles representing one portion. We need such 4 portions as electrons. That is 8 moles. Next one. Calculate the mass of zinc oxide. Mass of zinc oxide. So mass of zinc oxide can be calculated, right? If you know the moles of zinc oxide. If you know the moles of zinc oxide, you can calculate the mass of zinc oxide. Right? Maybe go on. We have some space, no? So moles of zinc oxide should be found, right? So what we know up to now is the moles of O2 as well as moles of electrons. So see whether you are with any kind of relationship between the zinc oxide with these ones. So you can use This equation or this one. No worries. I prefer you to go with this. මේ දෙකෙන් කැමති දේ යූස් කරන්න පුළුවන්. මම වාට කියනවා මේක යන්න කියලා. දෙකෙන් මේකම උත්තරේ එන්නේ. ඇයි මම එහෙම කියන්නේ? Here you are sorry, not here, sorry. Right? Here you are relating zinc oxide to the data given. Here you are using your zinc oxide to the data provided in the question. Here you are using the zinc oxide, here you are relating zinc oxide to answer which you have obtained. If the answer which you have obtained is wrong, you will come up with the wrong value for this one as well. If you are going with this relationship, as this is directly given, right, this one going to be wrong if you are using this value. Right? දෙකෙන් මේකම උත්තරේ එන්නේ ගමන් නැහැ. මේකෙන් හරි හදන්න. මම රිෆර් කරනවා මේකෙන් හරි. මොකද මේක කෙලින්ම ඩේටා දීලා තියෙන ඩේටා එක. මේක ඔයා කැල්කියුලේෂන් එකක් කරලා ඔබ්ටේන් කරපු ඩේටා එක. ඒතර මේක වැරදුනොත් ඔයාගේ මේකත් වැරදිනවා. කමක් නැහැ. දෙකෙන්ම උත්තරේ එනවා වැරද්දක් නැහැ. නමුත් අර සාමාන්‍යයෙන් එහෙම රිෆර් කරන ළමයිට. හරි? දීලා තියෙන කියන්නේ කියලා. So let's consider this one. Right? That is 1 to 2. Zinc oxide moles is twice of the O2 moles. O2 moles, 2 moles. This is going to be 4 moles. So what they are asking is zinc oxide mass, no? Mass. So if you know the moles, you come up with the mass by multiplying it with the G mole minus 1 value. Zinc oxide. Zinc coming up with 65, oxygen coming up with 16. This is going to be 81, no? It's going to be 324 grams. Right? Final stuff. Calculate the current passing through the cell. Current passing through the cell. Right? So to copy the current passing through the cell, we have to use the QUS ID. QUS ID use කරන දෝ IE හොයන්න බෑ නේද? current එක හොයන්න QUS ID use කරන්න ඕනේ. To copy the QUS ID as the T is provided, first you need to copy the Q. මේ goal එකෙන් හිතන්න. goal එක තමයි current එක හොයාගන්න එක. ඒ current එක හොයන්න දෙන communication අපිට QUS ID. QUS ID apply කරන්න මුලින්ම Q හොයාගෙන ඉන්න ඕනේ because T is given. So you need to compute the Q charge. We can find the charge with the use of moles of electrons. Q is equal to NF. Know the number of moles. Multiply this thing with the Faraday's constant. You can compute the Q. Right? Alright. Has it been ready? So you have 8 moles of electrons. Faraday's constant is 967,500. So that is multiplied by 8. right? Then find out the current. IO, simple IO anything. So Q is equal to ID. Q is found like this. I, that is what we need to find. T is 800 seconds. How to apply in SI units, right? I is just $965 now. The answer comes up with this side. Right? The question is answer again. Right, that is the 2020 LA question. Right? Okay, then you can try the few other questions have been there. What lamai question number 2 එක. ඒ කියන්නේ 2021 question එක කරන්න පුළුවන්. question number 3 එක. 2022 question එක කරන්න පුළුවන්. ඉතින් කරන්න. try කරන්න. Even the question number 4 can be done. You may not be able to do the ninth part, the last part of the question number 4, but rest can be done, right? So what team කරන්න පුළුවන්. 2024 question තියෙන ළමයි අන්තිම question එක තියෙනවා වගේ electrolysis ගැන. ඒක කරන්න බෑ දැන්ට. night session එකෙන් පස්සේ කරන්න පුළුවන්. හරි? අර questions ටික කරන්න. හරිද? night session එකේදී අපි electrolysis කතා කරමු. theory cover කරගමු මුලින්ම. එතකොට අපිට පස්සේ papers කරන ගමන් හරි electrolysis කරන්න පුළුවන් night sessions වල. හරි? එහෙනම් අපේ මේ night session එකේ අපි කතා කරනවා electrolysis. එතකොට theory ටික ඉවරයි. right? ඔයාලා questions ටික try කරන්න. 2 3 4 try කරන්න. හරි? එහෙනම් other than nothing. Right? Goodbye then. See you next week.